as an adsorbent for carbon dioxide. And in doing so, I was trying to look at which method that is the best when you're going to recycle plastic without emitting carbon dioxide. Because if I want to adsorb carbon dioxide, I shouldn't emit. So I came up with a method that is thermal and hydrothermal methods, which in books are used by different materials. So I was trying to see, can it be used on plastic? Can I improve it in plastic? And from there, I tried to characterize, then use it for adsorption. Next. So, in simple terms, when we are working on materials, we need to look at their properties. One of the properties that is common in plastic, it's called the glass transition temperature. We simply call it the TG temperature. This glass transition temperature, each material has a different glass transition temperature. And this is the temperature, when you heat a material up to that temperature, the material attains what we call the brittleness property. Even if it has been soft, and once you heat it up to that moment, it's going to be brittle. So that is the knowledge behind that I used, and heated up this PS and oil bath, and up to that temperature, then it became brittle, and I decided to grind it to powder. Next. So that powder, I needed to stabilize that powder. So I had to go, the first one is thermal method, the second one is hydrothermal method, to make it more stable. By the time it is in TG, that is before melting, so there is no emission of CO2. And that means I can easily convert it to powder. If you didn't know that plastic can be converted to powder. So after converting it to powder, I needed to stabilize it. So I had to use hydrothermal method. This is mainly water and simple potassium hydroxide at 200 degrees for 18 hours. Then after stabilizing it, I tested it next. I tested it using different techniques to see the properties that have been created within the material and see its application, whether it's going to fit my application. Next. So the first one, when you're going to use it for adsorption, it has to be the adsorption experiment. That is, we call it the BET adsorption experiment, to see whether the material I've created can take in and take out a sample. The reason why, just a minute back, the reason why I have this kind of gap, and for those that know adsorption and desorption, I was trying to see whether if I put this CO2 onto my material, it cannot easily be removed. That's why you're seeing adsorption is down, desorption is up. So you cannot easily remove that CO2. That means if I use it as an adsorbent, it can easily stay there with the pore volume of 0.68 and surface area of up to 300. Next. Now, after looking at what I'm going to use it for, I had to look at its morphology, how it looks. Is it looking like the way it was before, or it is now a different material? When you look at a block, this is the big block, you will see it's kind of like a solid, but inside the solid, it is just some small particles. And these particles are mainly, after stabilization, it is up to 95%. And by the time you're using styrene before, it is up to 70% carbon. So that means in between there, I'm trying to increase the carbon percentage and also introducing the oxygen that is required. Next. So before using the material for anything, you need to first confirm all the properties. I had to use TEM, is one of the techniques in microscopy that you use to see deeper beyond the first one you have seen for particles. The particles, if you look closely at 50 nanometers, the particles are on the side, but all these particles are reinforced with some kind of flakes and fibers within the material. That means this material is stable and it can be used beyond that. And then here, the Raman analysis is just to see that as I'm going to use it, how is its arrangement? We call it the disorganization of the materials before I introduce in something. This is just like when you're in a home, before you bring in a visitor, you need to first check your home. Is my home good for the visitor, or they're going to complain? So that is to see whether the material is well enough to receive. Next. So after that, I had to test this material for adsorption of CO2. And testing it for adsorption of CO2 is to see at what temperatures and what conditions are best when I'm using this kind of material. So I had to test it at different temperatures, that is 25, 60, and 80. 25 is our normal temperature. We call it the room temperature. Then also I had to use it at different pressures to see if it is 25, what is the best pressure if I'm to push in my CO2 into the material. So I had to use 1 bar, 0.5, then 0.1. Then this is the behavior for all the trials I did. But to make use of it, the green one is the normal environment. So I don't need to put extra heat when I'm going to use it as an adsorbent. And if it is that, that means this material can be embedded into the shoes. Because we have some of us that when you move a lot, your feet tends to generate a little bit of some uncomfortable environment. So if you use this material within your carpets for the shoe, it can easily absorb those materials without even increasing the heat within that. So that means when you use it at 25 degrees, that's the normal room temperature, you can easily absorb more. Once you increase the temperature, the absorption decreases. Why? Because I know people will ask why. Because this is a material got out of plastic. It is stable, yes, but the more you increase the temperature, the more you decrease the porosity and pore volume of the material. I tested that with a TGA to see, I think the results are not here because of time. So I tested that to see what happens when I subject this material to temperatures, elevated temperatures. So, and I found out that if you use it under normal temperatures, you can easily absorb more, and it can be used into our environment. That is capturing the CO2 without emitting it back to us. Then another person will ask, what happens after? So those kind of materials can again be recycled for different purposes. Next. So in conclusion, we can use these kind of materials in either as filters for CO2 filtering, or they can be even used in car exhaust, because nowadays we have these catalysts. When the car is moving, you can easily absorb a little of it, as long as your car does not reach 80 degrees. Because we all know that that exhaust sometimes is hot, but cannot reach 80 degrees. Next. And just a simple take home, I've done to PS, but there are so many other plastics. And for your information, I've worked on PET, then PE, but there are so many plastics that are available, and more plastic coming. We need to look into this kind of technology for different plastics and use them in different applications. That is industrial, if we want to eliminate the plastic. Next. Thank you. And diversity in research work leads to unity in the lab, because we always do different things. So that brings the unity. Thank you very much.
Thank you, Dr. Chigozie. At this juncture, we welcome any questions, comments in as far as his presentation is concerned? 2 or 3 questions from the audience. So maybe just a quick question for you.
Yes.
Now, what are the other applications of these materials you are deriving from plastics? What other applications? 2 or 3 other applications?
Okay. I've also tried to use it in energy storage. I have the data for supercapacitor applications. It's fairly good if it is a recycled material, and it can give the average or normal application for energy storage, so it's good. Then I've also used it in dye adsorption, that is for water treatment, and it is also working well. Those are the different applications where I've tried.
Yeah, thank you very much. Yeah, a question from the audience.
Yes, thank you, Moses, for the talk. My name is Joseph Dumbaranyaga. You know, sometimes when we solve a problem, we can end up creating another. So, have you done or thought of doing a life cycle analysis to check this new material, how it will impact our environment? I thank you.
Yes, that was, I did that when I was trying to check the BET analysis, because one thing, as you want to adsorb CO2, you don't want it to be emitted back. Will it be emitted back after a while? But when you look at the BET, it shows that the polystyrene has sites that can easily take the CO2 and it becomes part of that material. Same applies when you use it maybe in your canvas for the shoe. We don't want, after capturing that smell from your shoe, to come back maybe at night. So it becomes part of your material. But it reaches a time that it needs to be, because all materials have life cycle. If it reaches the life cycle, then you take it and recycle it, maybe use it for different, maybe I always tell people, use it maybe for construction, like the indoor construction where you don't expect to have water leaching and the rest. People are using them in pavers. Once it is put there, it cannot easily be emitted out because it is part of the material.
Thank you very much. Another question, maybe the last one.
Yes, thank you so much, Dr. Chigozie, for your presentation. I like the fact that you have considered that no emissions comes out of the process of producing the nanomaterials. And this might be related to this question on life cycle assessment, but what would be the energy cost of producing the nanomaterials from the plastic materials?
When you look at some of the recommendations, I did a little bit of the costing, but not to large extent. Like when it comes to polystyrene, for those who are recycling and they burn, put into an incinerator, they use a lot of energy. But here, I'm using like the oil bath, which is up to 100. And when you're to burn it in an incinerator, it will take more than 30 minutes for it to burn. But the end burning of an incinerator is CO2 emission and the rest. But here I only use like 10 minutes to make it that it reaches the glass transition temperature, then mill it out. So I'm using less of the energy consumption than that of commonly used for recycling. You said that's the last question. Any other question will come maybe when we are interacting.
You can interact with Dr. Chigozie later. Dr. Chigozie is one of the few people at Busitema University who is a holder of 2 PhDs. That's why he's called Dr. Chigozie. Thank you, Doctor.
Thank you, sir, and thanks everyone.
So our next presentation is going to come from Professor James Peter Egonyo, who also gave us the first keynote address. So Professor, you're welcome to give us the next presentation, if you are ready. While Professor comes to give us a presentation, Sally Kabasa should be preparing next. Thank you very much.
When the list was being read, I didn't hear my name again in this group, but I'm ready. Just the connection, I think, will take us, okay, it is here. Right, so welcome to this presentation, whose title is Recycling Biodegradable Market Waste and Local Brewers Spent Grain into Protein-Dense Animal Feed and Biofertilizer Using Black Soldier Fly. It's amazing to have this presentation after watching my counterpart present nicely how to deal with the non-biodegradable waste. And it is commonly known that of all that we see dumped, 70% is organic, and that is biodegradable. Now, this is a work done in collaboration between the Faculty of Agriculture at Arapai and the Faculty of Science and Education at Nagongera. My former dean calls us twin faculties, and he's here, I see him. So, just to add to the talk about waste, this is a recent report of UNDP that the burden of waste globally is on the increase. And in terms of managing this waste, talk about collecting it. Whereas other parts of the world are able to collect almost 100% of their waste and manage it, our sub-Saharan Africa collects just 36%. I recently interacted with the waste managers of Toxicity, and they collect only 24%. Now, in monetary terms, these are billions of money going in here to manage this waste. And directly and indirectly, waste management is worth hundreds of billions globally. My colleague hinted to this in words. I want to remind us this in pictures. that the problem is at home and solutions are urgently needed. Now, as a contribution to waste management burden, this group from the two faculties undertook this study to evaluate the potential of recycling biodegradable waste from the market and the local brewer spent grain. For people from Teso, we are talking about Adakai here, from Ajono, using black soldier fly, scientifically Ametia illucens, to produce animal feed in biofertilizer. That is the model that this team took up. In case you've not seen this fly, it is that fly getting its name from its color, the black one, and then it is out there. In fact, if you check properly in your dustbin, you'll find this fly. At least if you don't find the fly, you'll find the larvae like this. This is the fly. And so we, the project team is over there when they were inspecting the study trials which our students are undertaking. The ultimate objective of this project, funded by TBIC, is to produce these two products. The biofertilizer, which is residue from rearing, when the insect recycles the waste to get residue, and then the insect, which is an ingredient for animal feed. As we talk, we have already branded our fertilizer as Busitema University Insect-Based Fertilizer with Uganda Registration Services Bureau. And currently we also want to brand our larvae as a product. We tested 3 hypotheses. One was if the 2 sources of waste and their mixtures have effect on the growth performance of the larvae, and also the same treatments if they have an effect on the yield and quality of the fertilizer, and lastly, if the fertilizer coming from the different sources of waste has an impact, an effect on the yield, and we use on plant yield or crop yield, and we tested this with one short-term crop, Amaranthus vegetable. I think I've gone backwards. Our setup from the project involved initiating 2 rearing facilities for this insect. We have one in Nagongera, one in Arapai. Our students took on to use the facility. On the top left from my side, those are trays where we rear the larvae in racks. And then on the right from my side is the same picture of the team inspecting the student who was testing our biofertilizer, Buinfats, on Amaranthus vegetable. And at the bottom, we were blessed by hosting the director graduate studies at Arapai, and he witnessed how we are producing Buinfats. That is Buinfats being dried. Now, in terms of, we have too much data, but we give you a glimpse of what our findings indicate. The insect survival as one measure of performance of the insect on the different wastes. I want to first point out that wheat bran is a globally used substrate for rearing this insect. So if people were saying now this thing has been done, actually when we were defending this proposal, it has been done world over. It is known how to rear it, but it was not known that our local available waste has impact on the performance of the insect. You can test the soup here and see that our wastes perform better than, make the insects survive much better than the internationally used brewers' waste. In fact, one of the key persons in this country told me, if you want this project to succeed, not when you don't have brewer's waste, but now our waste and its combination makes the insect survive better than brewer's waste, wheat bran. Moving on, we are also looking at the bioconversion rate. We are seeing that especially market waste, even when it is added to our adakai, it makes the waste more convertible to fertilizer than adakai alone and wheat bran alone. And lastly, a test of the performance of the crop on the different wastes. For this, we used a commercial fertilizer as a control, and we also used the vegetable without applying any of the treatments. Clearly, the trend is showing that market waste wheat fats had the highest fresh weight yield of the vegetable. I know these data are having high standard errors, and so statistical significance is undetectable. But still, the trend is clear. And so with better performance, more experiments, including testing the application rate, we believe that bean fats will give us fantastic results. Now, in conclusion, waste type significantly affects the outputs we get from this project, or from the products we get from black soldier fly. And that means we have a chance to produce so many unique products. Even if it is fertilizer, we have different types of fertilizer with different compositions, with different performance level. And certainly, the data at hand is to see that we scale out the production of these products, not only for first for Soroti and Tororo, where these pilot production facilities are, but this is something that can run across the eastern region where the university is, and can also run across the country, so that we avert the Chitezi situation by turning this waste into wealth. Thank you so much for listening. I acknowledge the funding for this work and pray that our outputs will attract more funding to scale this work. And also, we had the privilege to be listened to by His Excellency, the President of this country, during the International Youth Day, where he piqued interest on our products and was engaging with our research assistant to understand what this is all about. Thank you so much.
Thank you very much, Professor Gonyu, for your presentation. At this juncture, I would like to invite some questions from the audience. Any questions? Maybe to lead the way, Prof. Thank you for the nice presentation once again. What could be responsible for the longer survival of the black soldier fly when fed on the local wastes compared to the wheat bran?
Yeah, the higher survival.
Higher survival, yes.
Yes. Insects are feeding on this waste because they are looking for nutrients. And also, the conditions which bring about, if you look at wheat bran, of course we moisten it so that it's also having moisture like fresh waste from the market. But humidity, the moisture content, and also the nutritional component is responsible for this. And I also need to inform you that part of this study is analyzing these wastes and also the products from the different treatments for nutritional value, and that is ongoing work. It will give us more explanation as to why this higher survival in our local available waste. Thank you.
Thank you very much. Any other question? If there are no more questions, let's proceed. Thank you, Professor. You may resume your seat. Thank you. I'm informed that Sally Kabasa is not with us here, and therefore we are moving to the next presenter. That is James Menya. Do you have James Menya? Please.
Thank you so much, Chair. All protocol observed. Good morning, everyone. James Menya. I'm here to present a paper titled Thermal Performance of a Flat Plate Solar Collector in Ugandan Climatic Conditions. This paper is co-authored by Professor Kant Kanyarusoke, Professor Wilson Babu, and Engineer Dr. Joseph Dumaranyaga. Slide. Okay. Given the exponential growth rate of the world population, taking a case of Uganda, for example, we were about 34.6 million people in 2014, but according to UBOS this year, we are 50 million people. That means there has been an average increase of about 1.5 million people per year. So this has caused depletion of fossil fuels given their limited nature, and this calls for alternatives. And these alternatives are renewable energy sources, which include tidal energy, geothermal energy, solar energy, and the wind energy. So there is an increasing need for these alternatives, and solar energy being widely accessible throughout the world has found much use compared to the others. So you find that the solar thermal collector, which is one of the components of the solar energy, is very important in a solar energy system because it does the work of absorbing the irradiance or the insolation and converts it to heat energy, which can be used in various ways. There are many existing solar flat plate collectors. However, their thermal performances have not been established, and this study sought to study the thermal performance of a stationary flat plate collector in Ugandan climatic conditions, particularly at Busitema University. So, solar performance, thermal performance of collectors is affected by a number of factors, and these include the tilt angle, the ambient temperature, the airflow, the flux, among others. So in this study, all these affecting factors were studied and analyzed for conclusions and recommendations. First, let us understand the solar system that was used for the study. It was a passive solar system that is composed of a flat plate, of a thermal, of a solar flat plate collector, which is this component on the top. It has a chute, and then a ducting, which are purposely used for channeling the air into the drying chamber. This is the drying chamber, where the products are put for drying. So when the air goes through this system, it is eventually drawn down from the chute, from the ducting, since it is now humid. Now let's understand the flat plate collector. It was a single glazing design fabricated from galvanized plate and aluminum angles with the specifications shown here. The length was 2 meters, the width was 1 meter, the area was 2 meters squared, and the depth of 0.1 meters. The collector tilt angle was 5 degrees, which is the tilt angle for Busitema. Then the back insulation thickness was 0.05, and the edge insulation was 0.05. The gap between the cover and the absorber was 0.04 meters, and the gap between the absorber and the back was 0.03. So the glass cover on the upper surface and the insulation on the other side limit thermal losses of the system. The instrumentation and measurement data was logged after every 20 minutes, and stored. And for temperature, we used calibrated having a range of negative 40 degrees to 1.5 degrees with an accuracy of 1 degree Celsius. And here we had 5 thermocouples fixed along the width, the length of the collector. This is the length, and these are the thermocouples. There were 5. The solar radiation intensity was measured using a calibrated ISM 410 model, having a range of 2,000 watts per meter squared and accuracy typically of 10 watts per meter squared. The mass flow rate was measured using an anemometer, but this actually measured the air flow or the velocity, which was converted to get the mass flow rate. Now, the modeling, we said we are looking at thermal performance. So when we talk about thermal performance, we are looking at efficiency particularly. And efficiency is given by the ratio of the useful heat to the incident solar radiation. But this formula was further broken down into the different components. The useful heat, which is QU, by equation 2, and then the mass flow rate obtained by equation 3. Then when you are trying to get the mass flow rate, there is a component of velocity, which is obtained by V times the area. Then the incident solar energy is a product of the area, collector area, times the insolation and time. Heat loss coefficient was also computed using equation 6. And then the performance evaluation was done by plotting efficiency and temperature difference and radiance. And then comparative analysis was done by measuring efficiency and the U value compared to industrial standards. So results and discussions, the meteorological data and experiments were conducted during the months of March, April, May, and July 2024 at Busitema University. And during this period, it was observed that the ambient temperatures ranged between 23 degrees to 37. From figure 4, which shows the variation of the black plate temperature during that day, it is observed that the temperature follows irradiance. When you look at this figure, we have 6 curves. This is the irradiance here. Then these are the various temperatures. T1, this is T5, then T2 and T3. So you find that the temperatures follow the irradiance throughout the day, and the lowest temperatures were observed at the entrance and exit of the collector, if you remember the structure of the collector. So you find that we had lowest temperatures at the exit and the entrance. This is due to the edge effect, because at the exit, we are losing heated air or warm air to the drying chamber, and then at the entrance, air from the ambient, which is of course at a lower temperature, is coming in. So some of the heat is lost to that air, increase its temperature. Additionally, the black plate heat at the entrance, okay, I've already explained that. Maybe I can talk about the, okay, so these, next slide. These graphs are similar to what I've been explaining, but just for the various months, April, May, and June. So we obtained the same data. From figure 7, 8, and 9, which is represented by this one here, you find that the ambient temperature, outward temperature, and irradiance across a typical day followed the same trend. And it is evident that irradiances increase from morning up 1 p.m. and then start dropping. This is the irradiance. Then these are the outlet temperature and inlet temperature. So the irradiance increases from morning up to 1 p.m. and then starts dropping. Several studies have studied effects of weather on the performance of flat plate collectors and found similar findings. The increasing trend of air temperature with irradiance is related to availability of solar energy to be absorbed by the air. This may also be explained by the fact that when the irradiance increases, there is a corresponding change in ambient temperature, which leads to a corresponding heat transfer from the glazing. So these are graphs for various days in the month of July. Next slide. This figure 10, shows useful heat across a typical day. And when you look at this figure, you find that it is evident that useful heat follows the same pattern as irradiance. This could be attributed to the higher amount of solar thermal energy that is available for absorption. Then we have tables for recorded data for ambient conditions. In the month of July, we took a sample of 3 days in July. And from those tables, you find that the maximum solar intensity during all the days was at 1 p.m. with values given. The range of ambient temperatures was between 23.4 and 37. But the maximum temperature differences were observed still at 1 p.m., except for 4th July. We all know that the Aphelion phenomena is said to happen on 5th July. That is when the Earth is farthest from the Sun, and we expect temperatures to be lower on 5th July. But for this case, these attributes were observed on 4th July. So it is reliable to prove after collecting some data for some period of time, maybe years. The maximum temperature without wet air for all the days was also observed at 1 p.m. I think you can see that there is something about 1 p.m. Okay? So when you also look at the maximum solar radiation, it is at 1 instead of 12 noon, because we all know that solar radiation is expected to be maximum at 12 noon, but in this case, we find it is at 1. This is because we are operating at a time zone, or local time based on a 45-degree marked time zone, which is the East African time zone. However, Busitema University here, main campus, is at 34.02 degrees east. So you find that there is a difference of 11 degrees. So that 11-degree difference causes our solar noon to be at 12:44. So if you want, we know that the Earth rotates at 15 degrees after every 1 hour. So when you get that 11-degree difference, and you divide it by 15, and then multiply by 60, you get the 44 minutes. So we are seeing this happening at 1 p.m. because it was the closest time of measurement. But the actual solar noon of Busitema is 12:44. So these the tables have been explaining. Then efficiencies ranged between 28.5 and 76 during drying hours. I have figures 11, 12, and 13 showing variation of irradiance, variation of efficiency and radiance with time. And from these figures, this is one of the figures, the others will be on the next slide. It can be observed that the radiance, high radiance leads to high black. It is observed that irradiance increases. As the radiance increases, the efficiency drops. This is the radiance. As it increases, the efficiency drops. Why? Because high radiance leads to high black temperature, which leads to high differences between the black plate and the ambient temperature. This creates a high driving force for heat loss potential from the plate, and it also implies that the system performs better at low irradiances. That is, it does that by being able to maintain low humidities and high temperatures in the drying chamber. This also suggests that other factors apart from irradiance affect the performance of our solar system, because one would expect that the performance or efficiency should be high at high irradiances, but which is not the case. The efficiency of the collector decreases as the day progresses and starts to rise after 1 p.m. And similar findings have been reported by other researchers. The hour of 1 p.m. with the lowest efficiency had the highest collector temperature, and this is because higher temperatures can lead to increased thermal losses. Next slide. So the effect of inlet air temperature, efficiency, and temperature difference was studied by analysis of variance. significant test using R Studio in R, and the findings show that the temperature difference, irradiance, and inlet air temperature have less significant effect on the thermal performance of the flat plate collector. This implies that there is a weak correlation between these factors and efficiency. And as you can see from tables 4 and 5, you find that the mass flow rate and thermal collector efficiency, tables 4 and 5 show ANOVA findings for thermal collector efficiency and the mass flow rate. And from these tables, you can see that the mass flow rate has a very high effect on collector efficiency, and this implies that efficiency of the collector is significantly influential or influenced by the mass flow rate. As the mass flow rate increases, the efficiency improves. Next slide. Next slide. Okay, so the average overall heat. Okay, maybe let's talk about the conclusions. The study fills a crucial research gap in the thermal analysis of flat plate collectors developed at Busitema University drying site. The system proved to perform better at low solar intensities by maintaining low humidities and high temperatures in the drying chamber. Findings, however, also depict that the drying should be done on a clear day. Although we are saying that it also performs better at low irradiances, but drying should be done on a clear day. This research also concludes that the design of the flat plate collector and the entire solar system should be improved to reduce high values of overall heat loss coefficients reported in this study. I want to thank you for your time.
Yes, thank you very much, James, for the nice presentation and for keeping time as much as possible. At this point, let's open the floor to questions. Just to lead the way, you've done this study over different months, but specifically, I don't know if it is the dry season or the wet season. So what is the effect of seasonality on the efficiency or the performance of the solar collector? You know, like if it is shiny days or when it is rainy season, there's not a lot of sunshine. So did you try to look at that?
Okay, thank you, sir. This is work in progress. What I've presented here today is data for the dry season. You remember that rain started around July, and we are still collecting data for the rainy season. So after that, we shall have a comparative analysis of that.
Okay, thank you very much. Any other question from the audience? Any questions? Yes?
Thank you very much, presenter. The first one slightly has been hit on, the issue of the seasons. Yeah, much as we might talk about the rain and dry, but also the other aspect of the equinoctial months of March, April, September, October. You need to look at it. Most likely, the thermal curves that you're having might be uniform in the equinoctial months. Because May, June, July, you're using only solstice months. Now, my second concern was also on the reason slightly you're giving for the sun radiance peaking at 1 p.m. Yeah, it's true because you could that in 2024. And 2024, you are turning towards the solar maximum. In most cases, the sun peaks later. If you're done it at solar minimum, you will find that it will be at exactly noon. Thank you.
Thank you so much. Those were very good for noting. I hope my colleague is noting for us.
Yes.
Professor Kant, you seem to have something to say.
Yes. Thank you for good presentation. My question is, what was the peak sunshine hour during the experiment? Thank you. For the whole.
The peak sunshine hour was 1 p.m.
Thank you very much. I think we shall end there. Thank you, James, for the presentation. You can resume your seat. Yes, yes, Prof.
Just come from Fort Portal, took off at midnight. First of all, let me make one more clarification about this business of solar moon. You see, the problem is this: East African Standard Time is based on the Nairobi longitude. Okay? So when we say noon, East African time, it's actually solar noon in Nairobi, not solar noon in Busitema. That should be very, very clear. Of course, you cannot define a standard time for every place. So the Mzungus who were here ruling this East African thing based the time on the Nairobi latitude for everybody in East Africa. So, definitely, our solar noon is closer to the solar noon of Rwanda and Burundi, because we are closer to the 30-degree east. We are closer to the 30-degree east latitude than we are to the 45-degree latitude of Nairobi. So, and this occurs in all what? In all solar studies. So I want to clarify that. So the thing is this, that we'll get maximum solar radiation here at our own local solar noon, irrespective of what is happening in Nairobi. So our solar noon, or our maximum radiation, is necessarily at, as he said, at 12:44, not 12:00. Okay, that is one. Now, the other thing I want to stress is this business of efficiency. We are so crazy about efficiency, especially the administrators. Okay? You see, the job must be done. These solar collectors are meant to collect solar energy, convert it to thermal energy of whatever it is whatever it is heating. That's the job. Now, the problem with the solar collectors, I think James didn't have enough time to explain it very, very well, is that there are so many competing needs for this heat. We call them thieves. There are so many thieves. When when the solar radiation is converted to heat, part of it is stolen by the sky, part of it is stolen by the air, everybody is happy. Only a fraction of it necessarily gets taken by the fluid, in this case air, drying air. Only a part of it gets taken by the fluid, but the other competitors are they are happy. So at peak, but in total, it gets much. It does a job. The corollary of this is this. Imagine that, okay, I'm into solar, okay, let's talk about crops. You see, our farmers, for instance, when they were producing little, okay, most of that little could be saved. Somebody doing an eighth of an acre, he produces, let's say, 100 kilos of maize. So he can conserve that 100 kilos of maize. But give him 2 acres, then he produces 1,600 what? Kilos of maize. He's not going to conserve the same fraction like he conserved when he had only 800 because of mass. He's not prepared. And this is the problem we are having actually in the country, that we produce a lot, we are increasing production, but then the ability to look after that production, the thieves, the weavers, even people, even rats, even whatever, they get happy. Everybody gets happy when he sees a mass, when they see a mass of 1,600 kilos. But when they see 800 or 200 or 100, a rich man, you've heard them, when he loses big. Okay? I think somebody lost hundreds of billions of dollars recently. My poor mania here, okay, 100 billion of somebody's 200 billion is 30%, is 50%. My mania here will never lose 50% of his salary, just like that. Okay? Because his is small, it's easily controllable. But when you go to the big scale, the efficiency drops. This we need to understand very, very, very well, especially the administrators. Yes, madam. So let me stop there. So in solar energy, therefore, what we are always interested in is what output. Do I get the job done? If I have supplied, say, 50 kilowatt hours in one day, I have received 50 kilowatt hours in one day, does my system give me 20 kilowatt hours, in which case it is 40% efficient? If it does, very good. But suppose I supplied 200, I would be happy, instead of getting 20 kilowatts from 200, I would be happy to get 30, to get 40, although the efficiency would be low. 40 out of 200 is 20%. So, but I get the job done. Because after all, I'm not paying for that solar power. So this is very, very important. You must know what you want. You want high efficiency with low output. You can get almost 100% with zero. With zero what? With zero input. Or very, very low input. Is that what you want? Definitely not. Definitely not. So the thing is effectiveness, and I think James.
Then also, as it is, you find we are putting near the wall. Sometime back, near the wall was follow. Right now, so what is to me when it comes to data storage, we are looking at convenience. If you come for this is anywhere, be happy without moving around. So that leads us to recycling of that. So if we recycle, what is the first is what is that? The second is how. So how comes in, which material are you using, how long are you going to have the energy? Then when we discuss up, of course all of us have device that is carrying battery. So at the end of the day, we can use these guys at the battery phase up. That's why I was asking people here at the wall, right? Because at the time you already have advantage at the wall, new device, or it is now. So when we the lithium ion battery, which we are all using in our devices, to come up with a better kind of device. So among the kind of electrochemical kind of materials that we use, we have the lithium ion battery, ones you're using, and have an issue whereby the life is less, but they can store much. So currently, people have capacitors, but the capacitor has an issue whereby for it has high recharge cycle, so it can store less. Is it an idea whereby yes, you store it. Why can't we get the battery? The capacity that type of high. So that brings us to hybridization. And when I say hybridization, most people think that we are going to pick the battery, put it here, bring the capacitor, put it here. No, that's not the case. Because at the end of the day, a battery has a size, a capacitor has a size, so you'll have something so bulky which might even bring in issues at the end of it all. So we utilize the mechanism whereby we can have a battery type electrode and a capacitive type of electrode, whereby battery is always negative because we are looking at the electrons, and capacitor we are always looking at how we can store, which is the anode. So what motivated me to this is most of the times you get materials, develop the technology, we produce products, but where do those products go at the end of it all? So I'm trying to work on this book. After use, can we come back to this? And with this theme of 2050, whereby we are looking at phasing out of diesel or internal combustion engine cars, it means the next step is electric cars. And you cannot talk about electric cars without storing energy. So that means batteries and all that kind of innovation of around storage of energy, they are going to play and they are going to stick. So what do? We can create a new device. Then also, look at this. Over 70% of the whole car that you see, the electric car, 70% goes to batteries. The other kind of the outboard and the board and everything, 30%. So why can't I focus myself around the batteries for this 70%? Then also, we are talking of mining. You can mine, use. So, shall we keep mining up to the last? No. Because you keep, these are kind of infinite deposits. Mine, use, that means the deposit is depleted. So, why can't we do urban mining, whereby we utilize the wastes and pick up the minerals from there for use? So, which brings to sustainability. Then I had to look at the problems associated with the batteries that you're using. First, they have the metals within themselves, that is lithium, manganese, nickel, etc., electrolytes, binders, and plastics. So when these are dumped to the soil, first they will go into the water, the groundwater. Second, when they are released, when they are dumped, when they combine with oxygen, there is a possibility of explosion. That's why it's hard for a person who's necessary specialized to come up and start opening a battery. At the end of the day, you can catch fire. Third is health. You're taking this water containing these heavy metals, and after taking them, they are going into your bloodstream. You expect cancer at the end of it or other diseases. Mining, I looked at it because we need sustainability in mining. Whenever you're using cobalt, lithium, and all these metals for battery production, at the end of the day, just know whenever you're mining, you're depleting. Then, what do we do in this case for this project? We looked at effective procedures of recycling first. Because there is you processing or recycling, but also you're damaging the environment using chemicals to recycle. Second, I had to look at which best alternative can we use. Can we get a data device that can, if you came here as an engineer, you sit here, you go back in your home in the evening with even some battery to take care of the night. So that's what I looked at. So how did I do this? First, I had to get the battery. In fact, I got around 100 pieces. And I did segregate to see whether it is lithium, maybe lithium manganese, lithium, let's say lithium manganese, lithium nickel, or I just picked at random. But in my results, it showed that almost I used all the batteries that we always use. So after that, after getting the battery, that dismantle. But dismantling, remember lithium has that tendency of reactive, it is highly reactive. So at the end of the day, when you're dismantling the battery, it can easily catch fire. So I had to deactivate it with sodium chloride. Then I opened, I crushed up, had to classify. Then from there, where I looked at recycling, is I never went into that of bioengineering and chemicals because I'm still looking at sustainability. So what I did is, I did this kind of recycling, whereby I had to use heat or drying and recover the metals. So from there, I had to get my recycled sample. I had to get my recycled sample and characterize it for physical and chemical properties. So, when we are preparing the hybrid of batteries, you know a battery is made up of two terminals, the negative and the positive. So I wouldn't only recycle to get the cathode, but also I looked at the anode. That's how I came up to prepare activated carbon from this local biomass. And I did want to taper with the environment on part of biomass. So I had to look at what is the risk that can be reused in that it cannot affect the community. So I had to look at the scopes, and I think Dr. Kilos did research about this. So I picked a leaf. So I had to do crush and size, then from there I carbonized, functionalized, and wherever you're seeing airtight, it's because I don't want moisture. You know, when you have moisture in the material, we are dealing with devices which has resistance. So that means you first use the energy in drying the sample as the material as you're using the device. So that's why I have airtight, so I characterize it also for these properties. I continue to do electrical chemical testing. Yes, the device we have assembled it, but does it store the energy? So I had to fabricate electrodes, which is the anode and the cathode, by that procedure. Next. From there, I had to do the testing itself. So during the testing, I had a challenge because there is a device that can measure the stability of that device, whereby you can say maybe my battery can operate in this kind of voltage, in this kind of current, in this kind of temperature and so forth. So the machine had not come, and here it has come. So what I utilized the meters available in the lab. So next, results. So first, you know you're dealing with crushing and grinding. You need to see how does particle size affect your device. These are devices where you're going to put in the car. The car is also combusting, doing this. So you expect the heat at the end of it all. So when you have the heat, does your material degrade and disappear? Or you still have the material to continue tomorrow? So when you look at this, you can see that a 75 micron and a 63 micron are giving a different peak. If you look at the 75, which is bigger, it has more water and impurities. When you look at the 63, minimal water. So from that, I said maybe again see if the smaller the particle, the better selection. Next. So if you look at the TGA results, with 63, the rate of mass loss is less, and the rate of mass loss for 75 is higher. So meaning 63 is my best option for me to continue for assembly. Next. From there, I have to look at my recycling. Is it okay? Because when you're recycling, you need to look at have you preserved, have you also eliminated the kind of contaminants or what was blocking your progress. So I looked at it and I continued with 63. 63 before hitting, 63 after hitting. You can see from here. 63 before, water is high. 53 after has reduced. Even it is almost not there. So impurity is 2. Before drying, you can see impurities are too high. So this, I had to come up with a conclusion to say that drying surely can do the work of recycling. Next. So I had also to look at heat flow. This is the material that you're going to use where you have such conditions. So if you look at DSC and TGA, you can see that this material absorbs the heat up to 450 degrees Celsius to become exothermic. And most of these cars, most of these devices, they operate around temperature of 100 below. So this showed me that my material can stay up to 450 degrees Celsius without being phased out or without being exothermic. Then also you can see, as the temperature was increasing, I was not losing a lot of mass until it was 800 degrees Celsius. And we cannot operate devices up to 800 degrees Celsius. So everything seems to be normal to me. Next. Next, I've already explained that. So I had to look at also same to look at the morphology. The morphology had everything that I expected, because when you look at the rocky surface with kind of lithiology, it meant that this material was charging and discharging. It brought up. It's the one which brought this. Then the nickels were nickel, and this was shown by this gravel. Then also carbon particles were shown by this kind of tube-like. So, and all these findings were aligning with the nitrous that I made. Next. EDX, that's what I started with. I went and picked all the batteries. I didn't select to say lithium, manganese, lithium, nickel. But when you come here, EDX was showing me, oh, even carbon inclusive. So, manganese, this, nickel, and all of them were recovered. Next. I had to do this, which is XRB, and mostly we are looking at the crystal structure. And mostly I did this to look at, I did this to look at coatability. You know, this material is supposed to be coated on an electrode. So the bigger the particle size, that means during coating, the material might not stick to the electrode. So at the end of it, all to will. So that's it. Next. Here I had to do composition, and other minerals were not seen by XRF. And the reason is the atomic mass of lithium is small to be seen by such machines. So we had to go for a flame photometer. Carbon was seen by this. So I did the same for carbon, activated carbon. Activated carbon I did the same, but activated carbon had the challenge of power size, because we don't have XPS and BET, which can give me the real power size and so forth. So I had to base on these same results to come up with, to see how the powers are arranged and which size. So at the end of the day, the device worked, and it gave us a capacitance of 6,500 per gram. And when you look at the battery, these normal batteries we have, they range between 2,000 to 2,000 to 3,000 of 4,000. So the device was okay for me, and we are looking at how to develop that if possible. So last. I want to thank Materials and Energy Storage Innovation Center. They supported me much. when it came to knowledge and some funds for experiments. Then UNSS also they helped me, Busitema University. I used the lab so much in the books. So we don't need to exhaust materials, splitting in our environment and ending up with nothing to continue with. The SIM, sustainability. Thank you.
Thank you very much, Exxon. Thank you for your presentation. At this juncture, I would like to ask, is a time for questions and answer session. 1 or 2 questions from the audience as far as this presentation is concerned. Maybe just a quick one. So you are using local available material to develop these batteries.
Yes, sir.
You've compared it. Is it superior to the existing technology? 1, 2. On the aspect, there's a side of motivation where you seem to want to recycle, the existing lithium batteries. Considering that they are rechargeable and they are used over time, what is the plan for collecting enough of these batteries for recycling?
The first one I didn't get.
Is your technology, the new using the local available material to develop this battery technology, is it superior to the existing technology, the existing batteries?
Okay, so mostly when you look at storage of electrons, we are looking at the anode mostly, because the other one contributes to electrons, but now we need to look at if electrons are produced, will they be stored and captured? And now most people have been using graphene, graphene oxide. But graphene and graphite, it has a tendency of restacking. It's like you have a paper like this, so at the end of the day it again tries to stick. So at the end of the day, capacitance reduces. But when you look at activated carbon, it has no challenge of that. At the same time also, graphite is mighty, but activated carbon is not just within the environment. So the capacitance of activated carbon is better than the one of graphene. Then the other thing you're asking about the sustainability of the recycle or the material. Of course, we have not seen any kind of recycling plant except that the one which have been established this year. So we've been using phones and laptops, I think, for over a decade. So where do you think those batteries are? And I know they are there. Because even if you throw them away, they will not decompose, they will be there. So we can reconnect and bring for recycling. So sustainability in that case is there.
Thank you. Any other questions from the audience? At this point, thank you very much. I want to recognize the presence of the Vice Chancellor, Professor Paul Bock. Professor, we are just ending the first session of the second Busitema University Science and Technology Innovation. The first session is coming to an end. At this point, I think I want to inform you that we are going for health break briefly, and after that, before we start the second session, the Vice Chancellor will greet us as we start the second session. So, for your information, the health break, we are going to have tea. So it is as you enter out on the left, you enter through the left or over those fences outside there. That is where we are going to have our refreshments. We have 30 minutes to do this, and when we come back, we shall go to the second session under One Health. The chair of the session will be Dr. Kamala Ebre. So everything should prepare accordingly for the next session. I thank you all. Thank all the presenters in the first session. Thank you. I hope we've learned something, and we've learned a lot from these presentations. And we shall continue to learn as we progress throughout the day. Thank you very much.
Thanks to everyone who has been in attendance. I think the level of discussions are rising higher and higher and higher. and I think we expect a lot to come. So at this time, we can have our break quickly, just
by show of hands, Kabari University. They're on their way, or perhaps they are having, they are on their way. Very good. They will be joining us shortly. We have researchers from Uganda Christian University. UCU, by show of hands, they are on the way coming as well, but I saw in the registry they registered. They are within. We have researchers from Gulu University. Gulu University, okay, I think they are within. We have researchers from Muni University. Muni University, all the way from Arua. Yeah, I think they are within. And we have researchers from Busitema University. Busitema, where are you? Wow, very good. You are most welcome, Busitema University. Members from other universities, we don't take, as you may know, Busitema is not only here. We are scattered all over the country. So members from, we have members from Soroti, we have members from Jinja, members from Bale. So when we meet here, we are not just Busitema University, but we are Busitema University in Pururo. Okay? And before us, dear VC, we have other institutions who are our associates, but also our sponsors for this symposium. We have, as I've already mentioned, members of the Fourth Estate, the media, our friends from UBC, you're most welcome. A big hand clap to them. I believe we are airing live at UBC. And we have members from Jubilee Insurance. Some members from Jubilee Insurance. They're outside, I think they have their tent outside. We have sponsorship from Airtel Uganda, MTN Uganda, Uganda Registration Services Bureau. Anyone from URSB? Probably they are coming. We have support from Stanbic Bank, STI Secretariat, Ministry of Works and Transport, the Uganda Revenue Authority, Absa Bank, and ultimately Busitema University Management. A big hand clap to our associates and sponsors. Without taking much time, our dear VC, it's time to, I would like to welcome you to officially open this symposium. You're most welcome, VC.
Thank you very much, Master of Ceremonies, Deputy Vice Chancellor, Academic Affairs, the Director, Research, Graduate Training and Innovations, Heads of Departments, distinguished researchers, ladies and gentlemen. Deputy Vice Chancellor opened this meeting, and I'm here just to give you welcome remarks and make a few observations. My name is Professor Paul Owako. I'm the Vice Chancellor of Busitema University. I'm saying this for the number of visitors whom I've had. Of course, before I came here, they told me that there were visitors. I said, who are those? They said they are professors from Mountains of the Moon. That is Professor Kanyarusoke and Professor Musinguzi. And I say, those are my people. They cannot be visitors in a place which they helped establish. Allow me welcome you people for coming back home after a short time. That means your heart is still in Busitema. Allow me welcome all the researchers from the universities mentioned. Lira University, I had Soroti University, I had Islamic University in Uganda, Mountains of the Moon, Uganda Matters, and so forth. It is a pleasure to receive you in Busitema University. And please let this be the beginning of long-term collaboration. While here, take off time to network with your counterparts so that in the future I hear of inter-university projects. I long to hear a project where Lira University is working with Busitema University and is working with Guru University to develop an innovation which is commercially viable. That should be the future of science, technology, and innovation in this country. Allow me to thank the organizing committee, chaired by the Director Research. The DVC academic, I think, was monitoring, and Moses Andima, and all your colleagues. It is a pleasure, and thank you for inviting us to attend this symposium. Previously, universities used to account to government in one major way. In the 1970s, the list of graduates from Makerere would be read on radio, and the whole country would be excited. And graduates constituted almost the sole most important output of a university. Of course, professors used to do research and publish and get promotions, but that was secondary and it didn't feature a lot. Today, the government of Uganda has put emphasis on science, technology, and innovation. And similarly, the accountability of universities has changed. If you produce graduates, bachelors, masters, PhD, people will say, yes, well done. But that's not enough. Then if you produce publications, again, people will say, yes, thank you very much. You've contributed to new knowledge, but that per se cannot develop a country. So we are now accounting on a new level. Activity. So I really look at this meeting as extremely important because it brings together top researchers from over 7 universities in the country to discuss the way forward on science, technology, and innovation. Do not forget the major areas which government has set: increased agro-industrialization, value addition on agricultural products. This is an area our country has very strong advantage over many other countries. Because of limited
value addition. I call upon you people to come up with ways in which we can add value to our agricultural products so that they can contribute to the economy. Of course, we have tourism, we have got mineral value addition, and the general science and technology like mobility vehicles, development of digital devices, and so forth. These are critical areas which our government has already identified, and we as universities should make contributions to ensure that we benefit from the resources that we have. Allow me in a special way mention our people who are spearheading centers of excellences, both in Busitema and the other universities. I'm a strong believer in the center of excellence approach. I don't believe that if you want to develop society, you reach out to everyone. You will fail, you will distribute resources so wide and thinly, and in the long run you will have no impact. But centers of excellence is the way to go. Let one person or one group of scientists excel, then the others should look at them and say, how did they do it? And they also start and they follow suit. So allow me to thank the leaders of the following Center of Excellences. We have a Center of Excellence in Natural Products Research. In Mbale, I saw many team members here. We have Center of Excellence in Renewable Energy, where some of you people who are visiting us from mountains of the moon helped to establish. We have Center of Excellence in Material Engineering. We have Center of Excellence in Artificial Intelligence. God River is there. Just stand up and wave to these people. So that, and artificial intelligence is one of the areas which universities and should pay attention to. You know, there are things can even take our jobs. Have you started feeling the fear? How can something, how do you ask a question, write for me a proposal on this, and a non-human being writes a proposal? Isn't this what teachers have been spending time on? So this artificial intelligence can render us, all of us, jobless. So make sure you pay attention to it, and universities should do internal reflection to see how we can respond to the developments in artificial intelligence. It seems it has capability to do almost everything. We have the soil science, these people in Yarapai, and many others. Allow me greatly appreciate these people who are championing these various areas in science and technology, and call upon them to strengthen and come up with products which we can commercialize so that the whole country benefits from our knowledge. As a university, we are continuing to focus on how can we strengthen science, technology, and innovation. We've recently built a technology and business incubation center, brand new building. It is going to be commissioned at our graduation ceremony as part of our efforts to ensure that we transit to fully fledged
innovations and commercialized products in the university. And we are continuing to look for resources to ensure that we support researchers. And similarly, government has done quite a lot. I've never seen, as a scientist, disinterest from government and the commitment of resources that we are seeing today from government. So allow me to take this opportunity to thank the government of Uganda for refocusing on scientists and putting resources into this area to ensure that we contribute to the national economy. As I end my remarks, allow me to thank the various teams which have made contributions, our internal team which has organized this meeting, our management which has supported this, the Ministry of Science, Technology and Innovation for the contribution of resources, Stanbic Bank, Centenary Bank, Airtel, and all contributors to the success of this event. I hope that in the future, this will be a major event, not only at Busitema University, but in the whole country as large, as brains come together to reflect on how we can strengthen science, technology, and innovation in higher institutions of learning. I want to take this opportunity to wish you fruitful deliberations, and I also want to wish you journey masses when you travel home. Take off time to look around Busitema University. We have a workshop behind you. We have laboratories in this building where you are, and make sure that you know what is available here, so that when you are thinking about collaborating with Busitema, you know exactly what Busitema can contribute. Thank you very much, and enjoy your stay in Busitema.
Thank you, our dear VC, Professor Paul Wako, for those words of encouragement to the researchers, and also for shedding light to the future of our efforts as scientists, as researchers, and also as frontiers of knowledge in this fast-growing, technologically driven era. What I've picked from him is that together and collaboratively, our impact can be felt. If we want to move far, we can move together. But if we move alone, we shall not move we shall move fast but not make significant impact. So, I didn't introduce myself. I'm by names of Mr. Ambrose Ashabahebwa, and I'm a lecturer in the Faculty of Engineering at Busitema University. I'll be the chair. I'll be standing in for Dr. Edwin Kamara, who is on his way, and I will be taking you through this session until when he comes, and I will hand over. Before we proceed, been advised that we shall have a symposium photo where we shall all be present to register our presence digitally, isn't it? So we shall have this photo in front of this building as you get out. So in the next maybe 2 or 3 minutes, let's handle this exercise. We get back and we get back to our presentations. Thank you very much. Just in front, yeah, we can get up and move out.
herbal preparations locally made by people. So the solution we proposed was to evaluate its acute and subchronic toxicity effects. We wanted to use an animal model of Wister rats, the female ones. They respond quickly to toxic effects of substances within plant material. Next, please. So, among other things, you can place the next. Among other things that are done, of course, you have to harvest it, you have to process it, you have to isolate compounds from it, so many other things. But that is not our interest for this presentation today. Our interest was on the method on how we were to do or to carry out a study on the proposed solution. The proposed solution is about finding its toxic effects and trying to understand those toxic effects and to see if we can do something about it and then use it. If we can't do anything about it, then advise people to stay away from it until we find out to use it. So we studied the albizia extracts, the ethanolic extracts, using the rat model, and the method we adopted was the LOX method. So we prepared it in different doses and administered it to the rats, and then we studied the acute effects, those that are rapid onset, but we also studied the subchronic effects, those effects that may occur in the animals after a prolonged period of time of about 28 days. Next, please. So on the left-hand side was a method we used for acute toxicity. We used doses of 100. The low doses we used were 100, 500, and 1,000 milligrams. And then the higher doses we used were 1,600, 2,900, and 5,000, all in milligrams per kilogram. And in that, go back please. In that we wanted to determine the lethal dose, okay, the median lethal dose. And also, at the end, we plan to sacrifice the animals and then look at the toxic, what the drug has done in different tissues within the animal. And those tissues, some of them, we were going to harvest them and study how they look like before and after the administration. Okay, the histological analysis. Then we also wanted to look at the biochemical analysis as well as the hematological changes, the changes in blood parameters, the blood cells and others, to try and see whether they remain within normal functioning levels or they have altered. Next, please. So when that was done, this is what was found out. At doses below 1,000 milligrams per kilogram, this plant had mild to moderate acute toxicities, and some of them include pyroelection after 30 minutes, hyperventilation after 45 minutes, and lethargy after 90 minutes. No death was recorded after 24 hours in the acute phase. And again, no death was recorded after 10 days. So, meaning if you are using doses of albizia at not greater than 1,000 milligrams per kilogram, you are relatively safe for the first 10 days. So beyond that, the story might change. And at higher doses, you see, we used higher doses of 1,600 milligrams per kg and then 2,500 milligrams per kg, and we found that the minimum dose, the maximum dose that did not cause death was 1,600 milligrams per kg. But animals were very weak, they were moribund, and almost the point of death, but they recovered at that dose. Beyond that dose, animals started dying, and the minimum dose that caused death, maximum death was 2,500 milligrams per kg. Those two parameters are very important for us to determine our median lethal dose, the LD50. So meaning doses up to 1,500, up to 1,600 milligrams per kg are dangerous doses. And then beyond that, then it is lethal. Now, additional signs of toxicity that were observed: loss of lighting reflex at 150 minutes, and then coma and death started to occur at 300 minutes. So with the other two results, we determined the median lethal dose at 2,000 milligrams per kg. Next, please. That is a summary of results. So now looking at, next please, looking at the effect on biochemical parameters, because whereas we have observed toxicities, but these toxicities are going to affect the body differently. So we wanted to find out how are these toxicities distributed within the body. So we found that after 28 days, the serum biochemical changes were unremarkable. There were no serious changes in the serum biochemistry, except on a few parameters. The alkaline phosphatase, which points to the liver damage. Also, the aspartate transaminase enzymes were elevated, were significantly increased at a dose of 500 milligrams per kg. The level of significance being at 95% confidence level. Then also, we found that this albizia, the biochemical parameters of lipid profile, the low density lipoprotein, and the triglycerides, which sometimes point to the bad lipid components within our system, we found that, interestingly, those levels were going down at a relatively lower dose compared to the doses, the 500 milligrams per kg dose that caused the ALP and AST to increase. But at a relatively lower dose, you find that the lipid profile improved. LDL and triglycerides decreased. So this also points to some of the ethnobotanical claims that albizia was being attributed to as being a medicine. People use it for so many reasons, including treating blood pressure. So probably it works like this, but this was a spin-off result because here we are looking at toxic effects, and then this came up. Next, please. Next.
Doctor, maybe you can summarize.
All right, thank you. Yeah, the hematological parameters were also unremarkable except for the red blood cells and hemoglobin. Okay, next. And then these are some of the pictures of the different tissues. We see that there is no significant lesions in the architecture, the histological architecture of the heart, spleen, and the jejunum. The jejunum is not yet here, but for the liver tissue, we are seeing that at a dose of 500, there are changes from the control group compared to the group that received a dose of 500 milligrams per kg. So there are histological changes within the liver. And other tissues, next, let's look at the other pictures. The other pictures are kidney and then the lungs. In the jejunum, you can see that the pictures of all the tissues from all the animals receiving various doses and those that were receiving the control, the negative control, they are all the same. But for kidney and the lungs, there are some changes that were occurring. For the kidney, you had a multifocal lymphoid accumulation in some parts of for the lungs, in some part of the lungs, and for the kidney, you're having also some alterations around the nephrons. Next, please. In conclusion, what we found out is that Albizia foliaria has moderate toxicity when tested in rats. We have not tested in animals and humans. So when you administer a single high oral dose within 24 hours, you will see some effects. But when you do repeated administration of lower doses for a longer period, up to 28 dose-dependent toxicities to the kidney, to the liver, and to the lungs. So meaning that if you administer Albizia extracts for a longer period of time, or products that contain Albizia, you are likely going to have toxic effects on those tissues. So there is potential toxicity that can occur to humans consuming herbal remedies containing Albizia coriaria. Next, please. And then, therefore, we recommend that this plant, Albizia, NDA should carry out in-depth toxicity studies on herbal products containing Albizia coriaria before approval. And this is very important because the plant has so many medicinal properties which can be harnessed as medicines, like we did harness it for when we included it in Tazikov. However, the effects are dose dependent. So therefore, if you manage the doses, you give it in moderate doses, there you can harness its potential as a medicinal plant and also reduce its negative effects as a toxic plant, because it's both medicinal and toxic. Also, before that, also more studies are needed. We need more studies to be conducted to confirm the phytochemicals responsible for the toxicity, because two things we can do with them. If the phytochemicals, we realize that they are the ones responsible for their efficacy, then we can isolate them, modify them, remove the toxic properties, and amplify the medicinal properties through structural activity modifications. We can do structure-activity relationship studies, and we see if those compounds are active, then what we do, we modify them. We can remove certain parts to improve their pharmacokinetics. Thank you. So let me have the last. This study was approved by our reg. You moved so fast. Okay, so, but it's okay, it's well. So this study was approved by our reg and was sponsored under Preside, which is now currently known as STI Open Ministry. Thank you so much.
Thank you very much, Dr. Maseruka. Any questions from the audience for Doctor? Any questions? Maybe as they are thinking, I have one small one. I'm just thinking about the method of preparation. Could there be any effect, or depending on the method of preparation? Maybe I assume you dry them, maybe using the sun or using incubators. Or could there be variability in terms of the impact on toxicity?
Okay, thank you. Our study here does not speak to that, but it is from ethnobotanical studies that information tends to come out. Even within the community, what caused the inconsistencies in toxicity is that the communities were reporting that the plant is toxic, and therefore you needed to boil it for longer periods of time. So that was not studied here. We could still further experiment it. But of course, the question is that long exposure to adverse environmental conditions could also destroy the efficacious molecules within the plant. So you might lose the toxicity, but also in the process lose the efficacy. So that needs to be further studied, but this study did not bring that out. Thank you.
Any other questions? Okay, maybe I can have one last one to represent the audience. In terms of the, you've talked about the active ingredients or the compounds which are responsible for the toxicity. Could there be natural neutralizers to these compounds responsible for toxicity?
Definitely. Something else that happened after this study, this plant was still further incorporated within our product. But when you study the toxicity profile of the product, it tells a different story from the toxicity profile of the plant itself. So some of these natural products still have compounds we are yet to understand. We are continuing to explore their chemistry, their structure, and to understand how they relate to the human body and other biological systems. Like in this case, we are using animal models like rats. So probably there are components within other plants that we put together that we have not been able to understand how those other components react or interact with the different components within Albizia. Of course, we are able to isolate the components within Albizia. You're able to see them. The major component we are targeting for the anti-inflammatory properties, the reason why we included it in Tazikov was betulinic acid. So you can know all those things, but how they've come together and counter each other's toxic profiles and sometimes efficacious properties, we are yet to understand that aspect, but we are still studying it. Yes.
Iruka Richard for that wonderful presentation. A big hand clap to Dr. Richard. You can take your seat, Doctor. And next, we are going to have Dr. Hokero Joseph. You're most welcome, Doctor. And he will give us a presentation titled Formulation and Evaluation of Herbal Products for HIV-1 Latency Reversal in Non-BHIV1 Viral Subtypes. You're most welcome, Prof.
Thank you very much, Chair of the session. I'm Joseph Okello, a senior lecturer and head of Biology Department at the Faculty of Science and Education here at Busitema University. I'm also principal investigator at the Natural Product Research and Innovation Center. And the work I'm going to present to you is part of the work, ongoing work, which was conducted there at the Natural Product Research and Innovation Center. First slide. So my talk is titled Formulation and Evaluation of Herbal Products for HIV-1 Latency Reversal in Non-BHIV1 Viral Subtypes. Next slide. So to better understand what HIV latency is all about, we need to look at the life cycle. So entry of HIV to a target cell is mediated through binding interaction of the viral glycoproteins with the receptor on the CD4 T cell. When it enters, the viral core uncoats, releasing the viral RNA, which is reverse transcribed or translated into DNA to make it compatible with the genetic material of the host cell. And when that happens, the viral DNA is translocated to the nucleus, where it is integrated to become part of the host DNA. So once integration has taken place, infection is done. So at that point, you can do nothing about it. Next. Now, the integrated provirus starts expressing the viral RNA, which is translated into viral proteins, which assemble to form new virion particles that bud out of the target cell. Then it goes on to infect other target cells, other new cells. This is the lytic pathway of HIV replication cycle. Next. However, in a small proportion of cells known as memory CD4 T cells, there is no transcription. The provirus is silent, is quiet, is not expressing new, is not making new virions, not making new virus particles, but it's just silent. And that is what we are calling HIV latency. But under certain conditions, when conditions are favorable, these latently infected cells, the latent results, they become reactivated and start producing new viruses that lead to rebounding viremia. Next. Next. So activation of cells through the T-cell receptor or T-cell receptor signaling, next, activates a transcription factor known as nuclear factor of activated T-cells, or NFAC. So these are transcription factors which is resident in the cytoplasm, but when cells are activated, they move to the nucleus where the latent provirus is located. They also activate nuclear factor kappa B, another transcription factor, another one called activator protein 1, or AP1, and all these factors together can bind to the latent provirus and regulate expression of or reactivation of HIV from latency. So reactivation of latency is just about producing new virions or new virus particles that go on to infect other target cells. Interestingly, they are natural products. Next, natural products that can also activate these pathways. For example, we have prostratin. Prostratin is a natural product derived from plant. It can activate NF-kappa B and AP1. Indianol, which is an analog of prostatin, can do the same job. Procyanidin can also do the same work. It can activate AP1 and NF-kappa B, and they also reverse latency. Next. So what is the problem? The problem at hand is that there is still a big burden of HIV in sub-Saharan Africa, where HIV is most prevalent and devastating. You are aware that new infections continue to occur. For example, in Uganda, it is reported that up to 51,000 new infections take place every year. So highly active antiretroviral therapy or combination antiretroviral therapy is able to extend life expectancy of people living with HIV, but it has limitations. One is that it does not cure HIV, so patients have to stay on medication for lifelong, rest of their lives, which is not a good thing. And yet these drugs have side effects, they are toxic side effects, and many patients end up abandoning treatment altogether. And when that happens, the consequences are so devastating. There's rampant drug resistance, high cost of treatment, and complications such as dyslipidemia, which it causes non-communicable diseases among people living with HIV who are on antiretroviral therapy. Now, efforts to reverse latency have utilized HIV and subtype B virus, predominant in the Western world, but non-B viral subtypes, which are predominant in sub-Saharan Africa, including subtypes A and B in Uganda, have not been studied. So much of the work on latency reversal is done on subtype B virus, which is not a problem in sub-Saharan Africa. Prostatin is a natural product shown to reverse latency in subtype B virus, but we don't know what it does to other viral subtypes which are present with us here. And yet it is isolated from Thymelaceae and Euphorbia family of plants. Now, despite having medicinal plants in this family of plants, we don't know whether they contain prostatin or other analogs. Next slide. So the solution, please. The solution in this project, we propose to screen and identify prostatin or related compounds in Ugandan indigenous medicinal plants and evaluate its efficacy in latency reversal in subtypes A and B, which are predominant in Uganda, and to formulate and evaluate our products containing prostatin or related compounds that are able to reverse latency like prostatin and for use in the management of HIV/AIDS and potentially cure HIV infection. So the bottom line is to come up with a safe herbal product used for managing HIV/AIDS. Next. What is the relevancy of this project? Presently, at the global scale, 39 million people are reported to be living with HIV/AIDS, and over 25 million of the 39 are in sub-Saharan Africa. That is about over 68% of global HIV prevalence are in sub-Saharan Africa. In Uganda, the prevalence rate is about 8%. That's about 3.6 million Ugandans living with HIV. Now, to develop a safe and herbal product that can reverse latency and potentially cure HIV will liberate a burdened population and exploit an available big market for HIV drugs. It will contribute to achievement of sustainable development goals, universal health for all Ugandans, which will help to promote healthy communities that will enable achievement of Vision 2040, National Development Plan 3 and now 4. And of course, the innovation will generate significant income that will contribute towards the projected $550 billion target and contribute to the tenfold strategy of the development of the economy. Next slide. Now, these are the project activities, what we set out to achieve, and their status. One, the protocol development and submission for Research Ethics Committee approval and registration with the Uganda National Council for Science and Technology has been completed. We completed plant collection and ethnobotanical survey. Plant processing has been completed. Formulation of the herbal prototype for latency reversal and branding is done. Now, when it comes to evaluation, We've also completed toxicity evaluation of the prototype, partially done phytochemical screening, and then what is pending is the determination of efficacy of the extracts and the formulated prototype, and also determining the contaminants such as the aflatoxins and heavy metals in the product. Report writing and dissemination is a continuous process. Next. So just to highlight a few things that we've achieved, protocol approval by Busitema University Faculty of Health Sciences Research Ethics Committee has been done. This is the approval letter in there from REC, and the registration with the Uganda National Council for Science and Technology. We have the approval letter there. So we are compliant in terms of regulatory requirements. These are photos reflecting on the process, what we've done as far as plant collection and processing is concerned. In A, we were in what category interacting with one of the herbalists, key herbalists in category Peso sub-region, where we are in the bush collecting plant specimens for identification, but also samples for processing. In B, you can see the PI harvesting sustainably some of the plants that were used. In C, we've brought the plant samples to the lab for processing. D and E, we are now processing the plants, the post-harvest handling. Next. So this photo is of the formulated polyherbal prototype, which we branded as Providine. So this is the polyherbal product comprising of 6 different medicinal plants. That after phytochemical analysis, we found that they add a lot of phytochemicals that we think can do the job of reversing latency. Next slide. This slide is toxicity evaluation of Providine, whereby of major organs, including the liver, the heart. So in the first set, we have the control experiment, the control group. Next, animals. This experiment was done in West albino rats. Animals were fed on 200 milligrams per kilogram of body weight of Providine, 400 and 800 respectively. And the histopathological analysis was done on these tissues to see if there are any changes in these tissues, just like it was done in the previous, you've seen in the previous presentation. So you can clearly see that when you compare 200, 400 and 800 groups of animals with the control, there is no visible changes in the histopathology, indicating that Providine itself is non-toxic when taken in moderate quantities, up to 800 milligrams. Next slide. This is phytochemical analysis of Providine. So on the y-axis in A, these are the 6 different plants that were used to formulate Providine. And on the y-axis, we analyze for the content of flavonoid. And you can see that we did flavonoid. Why? Because, for instance, prostatin, which we are interested in, is a flavonoid. So we wanted to see the total content of flavonoids in Providine. And you can see that Leonatis nephritifolia, the first one here, has very high amount of flavonoid. The least amount was seen in proton macrostarches. In B is the same set of plants as in A on the x-axis. On the y-axis, we analyze for tannins. Tannins, you realize that the prostaglandin, which we looked at as activating NF-kappa B and AP1, belongs to this phytochemical group. So again, Leonatis nephritifolia, the first one, has a lot of tannins, while the least content was found in Rhoesis stridentata. So what remains to be done is to tease out what are the active molecules in this flavonoid. Is it prostatin? Is it prostaglandin? What is it? Or any other analogs of those compounds. Next slide. So in as far as efficacy evaluation of Providine is concerned, studies are ongoing. In A, this was at the AIDS Support Organization clinic at Entebbe. So we have a trained nurse and doing counseling and obtaining informed consent, written informed consent from study participants. In B, after obtaining informed consent, blood was drawn from the study participants. So A and B was done at Tasso and Tebe Clinic. In C, the blood in B is being used to isolate peripheral blood mononuclear cells, which we have seen this is at the Uganda Virus Research Institute. So it has been since been stored in the liquid nitrogen through cryopreservation. We are mobilizing more resources to finish up the job. We are hopeful it will be done. And finally, here is report writing and dissemination. We've since published one article in Alien Journal from Cell Press on this study. And I must also mention that this work was presented at the Uganda National HIV/AIDS Symposium in Kampala in November 2023. And what we are presenting today is part of ongoing dissemination. So it has been disseminated and it is a continuous process. Next slide. So in summary, we know that HIV is still a big burden in sub-Saharan Africa, where it is prevalent and devastating with new infections that continue to occur every day. Highly active antiretroviral therapy is able to extend life expectancy of people living with HIV, but that has major limitations, as we've seen previously. Therefore, Proverid, which is a polyherbal prototype, is demonstrated to be non-toxic in vivo studies using West albino rats. And when fully evaluated and before, Proverid may be suitable for reversing HIV latency in non-B virus subtypes and used for management of HIV/AIDS with the potential for curing the virus. So here we believe that initially this product will be taken along with HART, the current HART regimens, but through analysis. So over time we keep analyzing and checking if it has gotten rid, the body has gotten rid of the latent reservoir of HIV, those latently infected memory CD4 T cells that I talked about. So at some point, at some time T, we believe that once the body has been cleared of latent reservoir, then it would be safe to move patients, to put patients off HART and possibly end treatment altogether. And at that point, if that happens, then we would have come up with a cure for HIV/AIDS. Next slide. I want to thank the government of Uganda through the Busitema University Research Innovation Fund for providing the seed funding in 2023 and 2024 funding cycle, which enabled this work to be done. The herbalists from Busoga, Sebei, and Teso sub-region for participating in ethnobotanical surveys, the AIDS Support Organization for allowing their clients to participate in this project, and I'm also grateful to Uganda Virus Research Institute for providing the laboratories for HIV bioassays. And finally, I thank the Busitema University Natural Products Research and Innovation Center, my colleagues, for coming together. And to you, the audience, thank you for listening.
Thank you very much, Dr. Carol Joseph, for that great work that you are doing and your team at BUNAPRIC. We really appreciate BUNAPRIC and your effort you are putting in to push this research. Any questions or comments from your side? Just raise your hand. Oh, yes, Prof.
Yeah, I think that we can just present my vote. I just wanted to just understand, this is not for a cure. Is this for a cure?
Ultimately, we are looking for a cure, Prof.
Oh.
Yes. Ultimately, that's the goal, to cure the HIV infection.
Oh.
Yes.
And I also wanted to understand that how to formulate and looking at the cure. I don't know if you have considered about whether there could be some outside.
Yes, we've done toxicity studies, and in one slide I projected histopathological analysis of tissues from the heart and other major organs of which we did in West albino rats. So we've used the rat model to test for toxicity. In moderate quantities, it is not toxic. And of course, with therapy, patients take small amounts of medication one at a time, and the limited dosage, for example. So under those conditions, it is not as toxic. But when you take too much of it, and with an overdose, then it becomes very toxic. So, but when taken cautiously, small doses at a time, it is non-toxic. Yes, that is a good question. Now, when we do efficacy study, we are also going to analyze the potential of this product to globally activate cells, global T-cell activation. For example, the reason why T-cell receptor activation or using antibodies that bind to the T-cell receptor to activate the T-cell signaling pathway to reverse latency, the reason why it has not succeeded is because it causes global T-cell activation. It activates non-specifically so many different types of cells, which makes it toxic in the end. Now, what we are yet to do, we will also analyze for T-cell activation markers when we are looking at the efficacy of the product. And if it is activating the dormant virus, but not causing global activation of the cell, then it is a good product to go with. So we are yet to do that analysis when we do efficacy. Yes.
Okay, thank you. Yes.
Thank you so much, Doctor. Dr. Chen here, Department of Anesthesia, Busitema University. Just a quick one. When you go to the clients, like at TASO, and you give them some of this medication, are you randomizing? Will you be able to ascertain differences in different groups, maybe those who did take the drug and those who took the drug together with their normal already prescribed medication? Thank you.
Yes. Now we are yet to reach the clinical trials, that level. We are not yet there. What we have done here, we've obtained peripheral blood from TASO clients who have been on treatment for a very long duration of time. The idea of getting those ones that have maximal viral suppression is not to look for the reactivated provirus, not the virus which is actively circulating and replicating in cells. So for patients that are on therapy for an extended period of time, for them they have maximum viral suppression, and then those are the patients we need. And we need to isolate resting memory CD40 cells from that blood, from the peripheral blood mononuclear cells that have been collected, isolated from patient's blood. So we isolate resting CD40 cells to work with specifically, because those are the ones that have the dormant virus. So this is ex vivo study. We are getting blood from clients, TASO clients, and doing analysis outside in the lab. We have not yet reached the stage where we have to randomize, give them placebo, give them the product, and analyze. So that will come based on the efficacy results.
Thank you very much, Dr. Okero. I want to appreciate your work, and we pray the prototype graduates into commercializable product.
Thank you, Chair.
Until we kick HIV out of Uganda.
Let's pray for that. Thank you.
Amen. Thank you. Wow. I'm told we have the online audience. And I don't know if there is any comment or concern from the online audience. We want to appreciate them. Okay. So I'm told there is someone who is coordinating the online audience. and we want to sincerely appreciate their attendance, and we look forward to their active participation in all these sessions. Our next presenter is Dr. Herbert Kiwalia, who is going to present to us his research entitled Implementing an Electronic Integrated Maternity Registry at Mbale Regional Referral Hospital. You're most welcome, sir.
Good afternoon. So first and foremost, I would like to acknowledge the generous support from ELCRI, the logo that you see down there below. That's Elgon Center for Research and Innovation. Then I would like to acknowledge BURIF, which have provided invaluable funding for this project. Without their backing, I believe this research and our efforts to improve maternal health through digital innovations would not have been possible. That's the very small team. My name is Herbert Kiwalia, and we have another member here, Dr. John Paul Ocheng, the one that has just spoken. He's also part of our department. So today I'm going to share with you the progress and insights we have gained from our ongoing project on the development and implementation of an electronic integrated maternity registry at Mbale Regional Referral Hospital. So maybe I'll start off with just posing a question. How many mothers do you think we could save if we had the right data in the right hands at the right time? It will definitely make a difference, right? Because we have a lot of data, but it's all paper-based. And we really struggle to access this data to make a difference. So in Uganda, like many countries, like many other countries, we are fighting to reduce maternal mortality, which is 4 times higher than the SDG 2030 target, as we can see. So every year, mothers die due to preventable complications. Yeah? And many of these tragedies occur, and one of the reasons is because we do not have timely access to the data that we collect, which we can use to understand what's actually really going on. You see, in Mbale Regional Referral Hospital, we've been using paper logbooks. The ones that have been to hospital know those big books that you always see on the desks. Those are the logbooks that I'm referring to. A midwife or a doctor writes down every detail in that book. And data that could save lives remains trapped in those books, even when you urgently need it for, say, maybe quality improvement initiatives. You would have to struggle to get that data to make any sense out of it. And the good thing, the AI experts are here, and these are some of the struggles when you have a lot of data, but then you can't really access it. So at national level, what is done currently, data is aggregated at facilities. They tally it and they send it off to the Ministry of Health. But then, of course, those aggregated numbers really conceal the most important stories
which is the stories of the individual mothers. So we are looking at patient-level data. That data is not utilized. The Ministry of Health will know that we've had, maybe this month we've had 50 cesarean sections, but then they don't know what is actually happening, the complications, yeah, of each of the mothers. So that's where the patient-level data comes in. You need that data. So, I'm not sure if that photo is clear, but we have a problem in Uganda, in most of our facilities. So we have an issue. They say that pictures speak 1,000 words. As you can see, we have an issue concerning the accessibility of patient-level data, which directly affects the care that is given to the patients. So for us to use data, we need to be able to access it easily. So ensuring accessibility of patient-level data at facility level is a primary concern for very many facilities around the country. So a few years ago, we were given an assignment to understand the maternity mortality situation at the hospital. And when we requested for that data, they pointed us to this room. And that's what we had to deal with. So this room was eventually demolished. But before that, it was where all the patient files were actually dumped. And there is basically no structure, no system, just piles of essential health records in complete disarray. So when we were tasked to find the records, it took us about 2 days just to locate the relevant patient records that we actually needed to determine the maternal mortality at the hospital. So this chaotic system sadly isn't unique to only Mbale, but you'll actually find it in very many other health facilities around the country. This is also another image. It's a perfect example of how unsustainable the paper-based system is. As you can see, this logbook, this is what is known as a logbook. So by the time you actually get to the end of that logbook, when entering those records, the first papers are already falling apart, making it very difficult to actually retrieve all the data. So important records become lost, damaged, or even very disorganized. So this outdated system not only creates a data retrieval nightmare, but then it also compromises on the quality and accuracy of the data that we collect. So such deterioration over time makes it nearly impossible to conduct any meaningful, maybe quality improvement initiatives that you have. So it's very difficult. So then our objective becomes very clear. So the major objective was really to improve access to maternal health care, patient-level data for research. So to do this, first we had to assess the current practices and the challenges that were being faced in collecting data. Then secondly, we had to design and implement an electronic maternity register. Then finally, we had to evaluate its effectiveness and usability for research and clinical decision making. So for our methods, this involved gathering feedback directly from the healthcare professionals who were using the system. We've already conducted the focus group discussions on the current practices and the challenges, and I'm pleased to share that the analysis is nearing its completion. Then, of course, we've also conducted some focus group discussions focused on evaluating the system's effectiveness, and the transcription process is actually also underway. Now, for our system design, we leveraged an open source software specifically called DHIS2, Tracker Capture. So this is the same software that the Ministry of Health uses, but it uses it at at the top level, at an aggregate level. We are using it, customized it, to be able to collect patient level data at hospital level. Then of course we incorporated the social indicators for the reports. So now these reports are now generated automatically. So previously you would find midwives seated for 2 days just counting the number of admissions they've had that month just to be able to make that report. Now that is all automated. They just have a dashboard in front of them, and they're able to extract this data and fill out the reports that they are supposed to. Then of course this data is encrypted and it's stored locally on a secure server in Uganda. We use a service provider called Renu that provides cloud services to most of the public institutions in the country. And of course, we comply with Uganda's Data Protection and Privacy Act of 2019. And this is a big problem actually, compliance with that act. You'll find that there are very many organizations, very many NGOs in our country, patient level data, but then that data is actually hosted, probably in a server in Germany, or which is not compliant with our regulations here. So this is an area that we need to do better. So that's just a screenshot of the system, what it looks like. It's the login system. Then, of course, this is also just a screenshot of the data entry form. And we make sure to use drop-down options a lot because it reduces on the time for data entry for the nurses. So if they don't have to type in a lot of data, ideally that should reduce on the time for data entry. Then we also use what is known as program rules that kind of reduce on the time on the irrelevant data that they have to fill in. For example, if a patient's HIV status is known, the system will automatically prompt for additional information like the results or whether the partner was tested. So you don't have that information there if you don't know your HIV status. So we make sure that the form is very brief and very easy for the nurses and the midwives to enter. So for our results, we've successfully captured over 3,000 records within the system since its introduction in July. This is a high volume of data, and it reflects how the utility of the system. Then we've also achieved automated reporting, like I mentioned earlier, so that the midwives don't have to sit down and start manually counting and tallying to be able to report this data to the Ministry of Health. It's now it's automatic. They just and send to the medical records department at the hospital. Then of course,
Mr. Herbert, you could summarize in 3 minutes.
All right. Then of course, completeness of the data has been boosted, and also real-time data access for the medical people has also gone up. So lastly, looking ahead, our focus is on ensuring, of course, sustainability of this system. And a critical part of the sustainability really looks at integration with the national EMR. So currently the Ministry of Health is implementing a national EMR that is known as eAfya. So maybe going forward, when you go to the hospitals, you will see your doctors seated in front of computers now and not paper. So we hope to integrate with eAfya on the grounds that the platform for the Ministry of Health collects the patient level data, then our platform is able to generate the reports for use. Then of course, in addition, we'll prioritize awareness and advocacy, which we are doing now. This involves ensuring that all stakeholders are fully informed about the system's benefits. And lastly, the outputs from this system, such as the reports and data analysis, of course, will help inform policy and also some quality improvement initiatives at the hospital. Yep. thank you so much for listening. I really appreciate your audience. Wow.
Thank you so much, Mr. Herbert Kawalia. Wow, it's mind-blowing what you are doing to really reduce the tenacity of the work at health centers. Any comments or questions from the audience?
Thank you very much for the work you're doing, Herbert and your team. I'm wondering, so who are the beneficiaries? Is it only, okay, who are the beneficiaries?
Yeah, so there are, of course, very many beneficiaries in this. One, the immediate beneficiaries are really the nurses and the midwives that we have at the front line. So instead of sitting down to actually compile reports at the end of the month, they have that extra time to actually attend to patients, because the system now does the reports automatically. Previously, it could take them about 2 days. Now it takes them a click of a button, and they have.
Why I ask that is, if I went to any hospital for antenatal visits, I assume your system is like accessible by all clinics. Are they able to see my data, based on what you're entering or what they're entering, or it's not yet at that level?
So in Mbale, what we have is a proof of concept. In Mbale, it's implemented in a few areas of the hospital. So it's implemented in the main operating theater. It's implemented on the ward where you go after a procedure. Then it's also implemented in at maternity as well. So it's able to track that journey from when you actually got a procedure till when you actually discharged from the hospital. So when you go to the ward, they won't have to ask you for your age. When you had paper, they would ask you that information at every point you have to visit. So what this system does is that now you have a pathway, and that data entry is streamlined, so you don't have to collect some data at every point. So basically, when you're in the ward, after a procedure, you're only interested in the complications you develop and your outcome.
To put the name, because the principles of anonymity might have been breached to some extent. Thank you. Maybe, what do you say?
Yeah, sorry. You said the name of the hospital? Oh, this one. Yeah, so this is a logbook, I think, that was used in 2012. And logbooks are actually, this is information that is, especially the covers, this is not privileged information, like the cover, at least. It's what's actually inside, yeah? The patient information, that is what is actually very privileged. That cannot be shared here. This is simply just a cover of a book. Sure. I agree. But what happens now, this is actually not unique to one facility. This is a situation that we have everywhere. So I believe this is not news.
Wow, thank you for, but I have one from my side as well, now from the engineering perspective. System flexibility. Is this platform flexible in a way that, because our facilities, they are challenges like any other institutions. Sometimes power is a problem, the computers are not powered, sometimes maybe
even internet
here and there.
Yeah, sure.
So, assuming there is no power and the computers are not charging, I see your platform is, there are so many areas to feed the data. And I'm imagining if there is a hard copy provision, and if it can be, assuming they record in a hard copy, and the power comes after 3 days, they have this long list. Is it possible to update this system, or it is real time, based?
Yeah, that's a very good question. So, yeah, those are some of the challenges that we faced. So one of the features of the open source platform that we use, known as DHIS2, it has a capability of offline data entry. So what this means is that, of course, it depends on the internet to actually run. You need to, when you're entering the records, you need to be connected to the internet. But then, situations when you're not connected to the internet, you're still able to enter that data, but then it's able to synchronize when you actually have access to the internet. For issues of power, the current model that we have a data validation person. So this person comes at the end of every day, and they're able to look out for how many admissions were at the unit, and then also how many actually have been entered in the system. So if there is a discrepancy, it's their role to actually help out, because sometimes the midwives are overwhelmed. There's so many, the emergencies coming in, mothers are delivering left, right, and center. So there is no way you tell that midwife to prioritize data entry over the care that they give to the mothers. So that's why we have a role of a data validation person at each of the units to help with the validation of the data.
Thank you very much. One last.
Just to emphasize a little bit more, because the question came, what's the actual, who the people benefiting from this system? My name is Ocheng, I work with Herbert. The system benefits everybody. The patient, we think that patient care will improve because we have real-time data. The system makes the work of the caregivers easier. The system makes the work of researchers easier. The system makes the work of people who make decisions much easier because they do not have to do too much. The challenge with aggregating data like that, most of us who have worked with data, is that it's difficult to find out the truth when that is how you keep your data. But when the data is digitalized, when the system can analyze, you just need to go, look in, and you can find many situations or understand many situations that you previously did. Systems like this have been tried before, but they have not been very successful in our settings. So we are trying to understand and build systems that probably work best for us, and that's what we are doing with this project. Thank you.
Big hand clap to Kawalia and his team.
Yeah, thank you very much.
Yes, Prof.
Just one more question. I'm just wondering, has it been only implemented at Mbari Regional Hospital, or it has been also tested elsewhere, like around, especially in the district or something like that, so that we're able to see the practicality and the usability of the entire system? Then secondly, you spoke about the Ministry of Health coming up with that general one. I don't know how you called it. So the general system of how doctors operate, from paper to E. So how will that system speak to the general system being rolled out by the Ministry of Health?
Thank you. Those are very good questions. So this system is the model that we are using. So we have what is known as, I didn't want to go too technical because of the audience, but this system, we have a model that we developed. So we have what is known as registries. Yeah. So basically, what those are instances of the system
being used depending on how you want to use it. For example, what I've presented is a maternity instance, right? But we've used it, we are currently using it at Busolwe Health Facility as a perioperative registry. That means as a surgical registry. So for all the surgical patients, that's what they use. Then we are also working with the Uganda Heart Institute, and we are at the stage of data dictionary development, and we are about to actually implement it there as well. We have also used it at, I think, which other facility? There is a facility, part of Mulago, I've just forgotten the name, but it's also part of the registries that we actually support as well. So now when it comes to the integration, the Ministry of Health is implementing what is known as EAFIA. Yeah? That's the system that's going to be used in all facilities around the country. That's the goal. Yeah? It's far-fetched, but it's the goal, and it has started. So the way this system comes in, where this system comes in, is that it has a feature of visualizations, dashboards, reporting. Okay? So simply collecting this data and not using it is not useful at all to anybody. Yeah? If you have a lot of data and you're not using it, you're not making any difference. So where this system comes in, it will be able to create visualizations, dashboards, for maybe the director in his office. He wants to know about the maternal mortality at his facility. He has a 50-inch screen on his TV, and he's able to see all this data in real time. Okay? So that's where this system comes in, because of its powerful visualization tools that it has embedded in it.
Thank you very much, Mr. Kawalia, for that wonderful presentation. A big hand clap for Mr. Hubbard. When I look back, I think some energy levels are dropping a little bit. Can I request that we all stand up a bit and stretch a bit? Let's get up a bit. Let's get up a bit. Let's get up a bit. Our energy levels are dropping. Yes. 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 I'm going to lead. Okay? Can you hold your waist like this? Very good. And then next be 60 degrees. Repeatedly 5 times. 1, 2, 3, 4, 5. Okay, return. You turn. 1, 2, 3, 4, 5. Very good. Everyone like this. Hold your hand like this. I think we don't have a slogan so far for conference. And I can see individually we are doing great. But collectively we can do even greater and greatest. So the Kenyans have their motto, Harambe. Okay? It means put together. Okay? Harambe. And then bravo means what? You can achieve greater, right? So we are going to have our slogan like this. Harambe, bravo. Okay? Back and put it on. Harambe, bravo. Harambe, bravo. Very good. You can have your seats. Our next presentation is going to come from none other than Dr. Chiemba Kennedy. Are you in the house? You're most welcome. And his presentation is titled Deciphering the Molecular Mechanism of Alloy Imodin in Managing Type 2 Diabetes mellitus and Associated Complications using Network Pharmacology, Molecular Docking, and Molecular Dynamic Simulation Approaches and in vivo experimental techniques. Wow, cool stuff. Our screen is on. I hope our online audience is following, and we shall get some responses from them as well. So let us know when we have some responses from there during the Q&A. Okay, it's coming. So you're most welcome. Kennedy, please.
Thank you, Chair. Good afternoon, members. Kennedy Chimba are my names. I'm a staff at the Department of Pharmacology and Therapeutics, Faculty of Health Sciences, Busitema University, but also a researcher at NAPRIC, that is Natural Products Research and Innovation Center. So I'm here to present part of our work that we are doing at NAPRIC. Can I have a screen?
It takes some time to come, so it's, but you can be, okay.
Okay. So, as the chair has set out the title, Deciphering the Molecular Mechanisms of alloemodine in Managing Type 2 Diabetes mellitus and Associated Complications using network pharmacology and molecular docking approaches. Importantly, this was an in silico approach or a computer-aided drug discovery approach. To give the discussion or the presentation a background, it's important to note that the burden of diabetes mellitus is high, the prevalence is high. Yeah? The International Diabetes Federation predicted the prevalence at 536.6 million as of the year 2021. The prevalence has been predicted to rise up to 783 million by the year 2045. There are quite a number of causes and risk factors. To mention a few: urbanization, reduced physical activity, and high prevalence of obesity. There are so many other risk factors such as age, overweight, physical inactivity, unhealthy diet, tobacco use, and family history. So quite a number of drugs are used in management of diabetes mellitus. Very important drugs, the oral hypoglycemics. The big one is metformin, sulfonylureas, gilbides and glipizides, and the glitazones. But however, these drugs are quite expensive, but also associated with a number of adverse effects, and also non-curative. Locally in our community, a number of plants are used in management of diabetes mellitus. But one of the important plants used by our community is this, aloe vera. In Uganda, it's called echigaji. I think in Ateso, it's called edoidoi. Very useful plant, traditional in management of diabetes mellitus. And the pharmacological properties of this plant have been associated to one of its important compounds, that is alloemodine. So scientific studies have evaluated the different pharmacological properties of this compound, and it has been reported that alloemodine has potential anti-cancer properties, it has potential anti-inflammatory properties, it has potential hepatoprotective properties, and microbial properties. But importantly, how does it work? It is a big question. And it's a question that applies to most of our herbal medicines. How do they work? That is unclear even to alloemodine. So at NAPRIC, we decided to use computer-aided approaches to understand, to elucidate the possible mechanisms of action of aloemodine. And aloe vera is also a key ingredient in one of the products that we're developing at the center. So it's very important we understand how our product treats diabetes mellitus. So allow me to take you through our journey. How did we conclude with aloemodine? Of course, we started with literature. So there's overwhelming literature about the various pharmacological properties and activities of aloemodine through databases like PubMed, Google, Scholar, Inari, PubChem, Cielo. Aloemodine is overwhelmingly reported and mentioned in all those databases. So the next thing we did is to understand the drug likeliness, the pharmacokinetics, and the toxicities of our compound aloemodine. So we used online platforms to understand the pharmacokinetics. Pharmacokinetics, how aloemodine is absorbed, how it is metabolized, how it is distributed, and perhaps eliminated in the body, and also the potential toxic effects of aloemodine. So the next thing we did is to understand what are the possible targets of aloemodine in the body. What molecular targets does aloemodine interact with in the body? So we used a number of bioinformatic platforms like SuperPredict, TargetNet, Swiss Target Predict to predict the possible targets of aloemodine. The next step was to understand, to collect and mine the various potential targets for diabetes mellitus, drug targets for diabetes mellitus. And we got these targets from a number of bioinformatic platforms like GeneCards, DisGenet, and Omim. So after collecting the potential targets for aloemodine and the various targets for diabetes mellitus, we established associations between these two. Are there any links? Are there any connections between the potential targets of aloemodine vis-a-vis the drug targets for diabetes mellitus? And in this, we're able to come up with a network. We constructed a network made up of various proteins. So which proteins are encoded by genes? So we did the gene ontology studies to understand the various cellular processes that these genes are involved in. So the next thing we did is to do cake analysis to understand the various pathways that these genes are involved in. And another thing that we did is to now dock. We assessed whether aloemodine can dock or can bind to these potential targets. And we did molecular docking. Of course, we prepared our targets. Our targets those are the genes or the proteins. And we also prepared our ligand, that is aloemodine. And then we use autodock tools and other important softwares like Avogadro, Chimera X, Discovery Studio to understand how aloemodine interacts with the potential targets in diabetes mellitus. And through this journey, we've been able to elucidate the possible mechanism of action of aloemodine, which is a key phytocompound or phytoconstituent in aloe vera. So these are our results. To start with, the drug likeliness or the drug likeliness prediction, the pharmacokinetics and toxicities of aloemodine. Does aloemodine look like a drug or a potential drug? This is what these results are informing us. So important parameters were assessed. Number one, we started with the molecular weight. And aloemodine has a molecular weight of 270.24 daltons. When given orally, aloemodine has a very good oral absorption. So that means it has a very good or unappreciable bioavailability. When you look at how it is metabolized, two important enzymes metabolize or inactivate allohemodine. One of them is CYP1A2 and also CYP3A4. This informs us that there is potential drug-drug interactions because these key enzymes are also involved in the metabolism of quite a number of drugs that we use clinically. But we also assess the bioavailability score, how much of allohemodine can get into the systemic circulation. And our result is it has a bioavailability score of 0.55. So the next thing we did is the potential organotoxic effects of allohemodine. And from our findings, allohemodine has no effects on the liver, it has no effects on the skin, it's not a carcinogen, but importantly, there's potential for skin sensitization. So, in summary, this ladder represents the pharmacokinetic properties of allohemodine. It has a very good lipophilicity, it has a very good size, it has a very good polarity, it is not insoluble, it has a very good saturability, it has a very good flexibility. Then we applied a very important rule, what we refer to as the Limpisiki rule of 5, for any orally administered drug should at least conform to these 5 rules. Rule number 1, any compound or any drug should not have more than 5 hydrogen bond donors. Then allohemodine had 3 hydrogen bond donors. Next, not more than 10 hydrogen bond acceptors. Allohemodine had 5 hydrogen bond acceptors. Molecular weight, not less than 500 Daltons. Allohemodine has a molecular weight of 270.24 Daltons. And lastly, a lipophilicity of not greater than 5, or a clog P of not greater than 5. Allohemodine had a very good result in this regard, a clog P of 1.82. So actually, allohemodine is a potential drug candidate. So also rotatable bonds, it has 1 rotatable bond. And the next thing we did is to identify the potential targets of allohemodine. So these are our results. Allohemodine has 237 potential targets in the body. There are 703 possible targets for diabetes mellitus, drug targets for diabetes mellitus. So we analyzed the intersection between these two, and we identified 32 genes that are common with allohemodine and with diabetes mellitus. So we constructed this network, but however, this network may not make sense unless you do some statistics. So we identified that actually these proteins or these targets are highly enriched, or they are associated, they are interlinked. This gave us confidence to move to the next stage, or to the next step. So the next thing we wanted to understand is the different cellular processes that these genes are involved in. Number one.
You can summarize in 3 minutes.
Okay, thank you. Number one, in terms of biological processes, our genes or our targets are involved in the negative regulation of apoptotic processes. But also, they are involved in the positive regulation of transcription from RNA polymerase. In regard to cellular components, they interact with components in the nucleus, components in the cytosol, and components in the cytoplasm. In regard to molecular function, These genes are involved in identical protein binding and enzyme binding. So the next thing we did, the KEGG enrichment analysis, understanding the different pathways that these genes or the proteins that they code for are involved in. We noticed that they are involved in a number of pathways, and the topmost is apoptosis, the second is lipid and atherosclerosis, but importantly, at the bottom, we noticed that these targets or proteins are involved in insulin resistance and in the pathophysiology or pathogenesis of type 2 diabetes mellitus. This gave us confidence to move on to the next stage. So the next stage was to identify what are the hub targets, what are the key genes that are associated with allohemodine and high associated with allohemodine vis-a-vis diabetes mellitus. So we identified the hub targets, and we applied 3 important algorithms. One is the maximal click centrality, the maximum neighborhood component, and the degree of nodes. So we identify these 9 genes as the key genes that if we are to develop allohemodine into a drug, these are our possible targets. We noticed that we have proteins like the tumor protein 53, epidermal growth factor receptor, saturnin 1, albumin, the beta cell lymphoma 2, caspase 8, tumor necrosis factor. And when you read about these genes, they are highly associated with the pathogenesis or the pathophysiology of diabetes mellitus. So the next thing we had to do is to do docking. Okay? These are the hub targets, but how do they associate or interact with our ligand, which is allohemodine? We noticed that they all have very good binding affinities. But importantly, we noticed 2 important targets. That is tumor necrosis factor that has the highest binding energy of -7.75. And these are its residues, but also identified another target, important target, the peroxisome proliferated activated receptor gamma. And that is a very important target. Why? Because quite a number of drugs and diabetic drugs on market, the glitazones, drugs like losiglitazone, pioglitazone, which are very good drugs in management of diabetes mellitus, are actually agonists of this receptor. And the interaction demonstrated a very good binding affinity of -7.27. So this gave us more evidence to move on to the next step of understanding now how these are the docking images. I want to conclude with the results of molecular dynamic simulations. The story would be incomplete if we don't do molecular dynamic simulations.
Maybe in 2 minutes. 2 minutes.
Okay. So we wanted to understand how the ligands interact with the target or the proteins, for how long, and how close the proximity of this interaction. That is why we did the molecular dynamic simulations, and our results show that there is a good interaction between tumor necrosis factor and PPAR gamma with our ligand, that is allohemodine. So from the interest of time, let me move to this. Our major purpose was to decipher the possible or the potential mechanism of action of allohemodine. And this is what we concluded with. Allohemodine targets a very important protein, that is tumor necrosis factor alpha, that is involved in the modulation of a number of downstream messengers, second messengers, that are involved in the pathophysiology of diabetes mellitus. So that is one possible mechanism of action of allohemodine. And human necrosis factor is involved in pathophysiological processes like the pancreatic beta cell apoptosis. So if we are able to target and block its effects onto these downstream second messengers, we could be able to control diabetes mellitus. But also, lastly, we can target the receptor PPAR gamma. That receptor is involved in a number of processes. Importantly, in adipocyte differentiation, in fatty acid storage, and glucose metabolism. That is why the drugs that I talked about are very important in managing diabetes mellitus. So, similarly, could also manage diabetes mellitus by targeting this important pathway. So we conclude by saying that alloemodine exhibits strong binding affinities for tumor necrosis factor alpha and PPAR gamma. And however, it's important to note that this is a purely in silico study in computer. So to validate these findings, we need more advanced in silico techniques, but also more in-depth in vitro assays and more in-depth in vivo experiments. So the in vitro assays are currently undergoing at Uganda Virus Research Institute, but also the in vivo experiments are being undertaken at COVAB, Makere. We acknowledge our funder, that is STI-OP. Thank you for listening.
Thank you very much. Wow, very inspiring, and such a product for managing sugar. Sugar is a big problem to many of us, many of our parents, many of our friends. Very good. Any questions or comments from the audience? Yes, Doctor.
Thank you so much for that presentation. Also very easy to follow. It's a computer-based investigation. My first question is, basing on previous experience with such computer-based investigations, what is the likelihood of in vitro or maybe in vivo success? Then the other question is, if this drug binds on TNFA, what are the chances that other medication in diabetes bind on this or interact with this receptor? And wouldn't it be a challenge if other medication that don't bind on this protein, rather that treat diabetes don't bind on this? I know you may be looking out for a new, rather like prevent progression, but does the protein interact with so many other processes? Can you test this, maybe on a computer? Thank you.
Okay, thank you, Doctor. Starting with the first question, it's important to note that during COVID-19, quite a number of drugs, their approval was accelerated based on computer-aided drug discovery approaches. Drugs like remdesivir, drugs like Silofovir. So based on computer investigations, their approval was accelerated and they were put on market. So chances, we are hopeful that actually the in vitro and in vivo experiments could be successful. In regard to drug interactions vis-a-vis the target human necrosis factor alpha, the other drugs, oral hypoglycemics, have other mechanisms of action that are not similar to what alloemodine has demonstrated here. But importantly, we would be worried with the other receptor that I've talked about, the phelixosome proliferated activated receptor, gamma, that is a target for drugs like glitazone and pioglitazone. That is where we could expect a potential drug-drug interaction if alloemodine is co-administered with such agents. And actually, it is also important because in community, you find that our people usually use these herbal medicines together with the conventional medicine. So it could be a message to our people in the public to cautiously use alloemodine or other herbal preparations if they are on conventional regimens. Could be a message to the community.
Any other questions? Any questions from the online audience? No? Yes, Prof.
Thank you, Kennedy. You're doing a great job at NAPRIC and your team, the entire team. Thank you very much. I just caught a line there which you put, and you said bioavailability score of 0.55. That's 55% for alloemodine. It's quite interesting a name. I've never even heard of it. So, but my question is that, isn't it good for drugs to have a bioavailability score of maybe 100%? If it is so, and if it varies, and this is oral, if it is going to be taken orally and is having 55%, now if you factor in the metabolism, digestion and stuff, would we have a less percentage? As a layman, I don't know, what do you think? I'm a layman in those things. Thank you very much.
Thank you, Prof. It's important to note that every drug developer would wish his drug to have a bioavailability score of 100%, but it's not possible. Biologically, it's not possible. Very few drugs, actually, no drug, unless administered intravenously, but given orally, no drug has 100% bioavailability. That's important to note because the moment it gets in the body, before it gets into the systemic circulation, it has to go to the liver. And the liver was designed to detoxify. So there are metabolic processes that often detoxify any exogenously administered agent. So the same applies to alloemodine. So, but with this information that we have, bioavailability score is almost close to below average, 0.55. There are other possibilities that we can explore. One, perhaps increasing the dose when administering it, factoring in that the 50% when administered 500 milligrams, 250 milligrams could be metabolized. So we could, instead of giving 500 milligrams, we could give 750. So that if half of 750 is metabolized, you have the required amount or plasma concentration of this compound to offer a therapeutic or to cause a therapeutic effect.
NAPRIC has done a lot of work, especially with herbal formulations, and it's very good. And we need to applaud you people for ensuring that African medicine is coming up professionally. However, I have not seen deep, because these days AI people use things like deep learning, deep everything, deep tech, deep. So I haven't seen deep collaboration between NAPRIC and the Faculty of Engineering. Why? For instance, some of these drugs, I would think of, now if we are having a bioavailability score of 0.55, how about maybe exploring using patches through nanotechnology? Something you can put on the skin and the drug
is absorbed into the bloodstream. And this is where engineering would meet and prick and develop some of these cutting-edge products. So I haven't seen that yet. Thank you.
Yeah, sure. That is a very important point for putting forward. And one of our chief scientists, that is Dr. Andima Moses, is leading us towards that. He's a very good guy when it comes to, very good scientist when it comes to nanotechnology. And hopefully you'll be able to establish a collaboration between NAPRI and Faculty of Engineering. That is a welcome submission.
Thank you very much, Doctor. But maybe he said he was speaking from the layman's language perspective. I also come from the layman's clan. Now, this alloy emodin, I assume it's an extract from aloe vera, right? Ish.
In a layman's language, we could consider it as an extract, but it is a pure compound.
It's a compound. Now, we are talking about sustainability, resilience and sustainability. I'm trying to imagine, you mentioned that sometimes the molecular weight of this compound, varies from, I don't know if it is species-based or environment-based, based on the environment where this plant has grown. As you may know, if you have these small eggplants from the bush, more bitter, compared to these ones which are cultivated. Maybe also the aloe plant is this one which is in the bush, wild, very bitter. And maybe this one which is cultivated, maybe a little bit mild. So is this variability in molecular weight environment-based, based on where the plant has grown, or is it species, can I call it a species, or like a variety-based? And your threshold, you have a threshold which can perform best for your formulation. I don't know what, how you can moderate that molecular weight for purposes of sustainability. Maybe if you want to grow, because after formulation, maybe you want to produce. So for sustainability, how do you ensure this threshold is met?
Thank you, Chair. Importantly, both the environment and interspecies variation could influence. Yeah, and you have no control over that. The best thing you can do is to grow your raw materials in a controlled environment. That is why at NAPRIC we are establishing a botanical garden, and we seek for more support from the university in that regard. We want to start growing all our raw materials in a controlled environment. But we can also explore some other techniques by technological approaches. Yeah, we could use biotechnological approaches to synthesize some of these important molecules in the lab.
Very good. The online audience, are we together? Any questions? Okay. Thank you very much, Dr. Kennedy and your team. A very big hand clap. We have one last, but this time it's not Dr. Andima. Dr. Andima swapped. He switched with a great woman, Dr. Omugisha Godliver, the director of the AI group, Artificial Intelligence. The VC mentioned that we need to be worried about what AI can do to us. So she needs to arrest our fears, if we are safe or not,
But we are glad to have you, Doctor. And the floor is yours. You're most welcome.
Thank you very much. Thank you very much, and to everyone who participated today. It's really nice to see such a big, diverse audience. As I wait for this part, they told me to talk about.
Maybe you can increase the volume a bit.
Yeah, I'm not used to these microphones. Most times I could be like on an open, But anyway, so looking at think about what other people have talked about, especially the last speakers, it felt like, they are part of us, or much as we are really, working on things like separately. However, I feel like what we are lacking at the moment is the multidisciplinary element, having people of the health sciences getting closer to us, or us getting closer to them. I've always asked for that opportunity, but I'm sure that everyone is seeing that today. I wait again. Okay. Yes, so as I wait for the projector to come on, I'll be giving some highlights on AI, artificial intelligence, and data science. And we can already see most of the case studies here where we could tap in how we could utilize the use of this data science and the data that we have. So, yep, thank you. Yes, so my talk is about how we can use AI, data science as a powerful tool in this scientific era of research, and innovation. So all these things that we had are really like good case studies. And also, I'm going to highlight a few things, and then we see how bring the element of AI and data science where we can optimize it, utilize it to make a better impact on our societies. I'll be very short because I know I'm standing between here and lunchtime, but about 15 minutes or 20. So you hear something to do with a bit of definition or why do we need interdisciplinary research. I'll give some highlights and then I'll talk about some key projects and then we can conclude. I don't know if this is very broad enough, but in the 21st century, why do we need data science? Or why do we talk about AI? It's already evident. The Vice Chancellor was here early in the morning telling us things AI could do, Not until recently, I think, people were taking this AI thing seriously, right? But today in academia, because we know we can use it to do our projects, we can ask any questions that are around, our academic work. So we are getting to appreciate that AI can really do something. But this has been on over a long time. So the questions that we need to ask is, why is data science important? What is data? Why big data analysis? And as someone who is really, getting into this lab of artificial intelligence, they have maybe other many questions around it. So I just put here a picture to give you an understanding to see where each one of these things lie. When you're doing your research, I've had a lot of data here, a lot of data from health sciences, but I don't know how they are keeping their data, how they are analyzing it, how they are preparing it, or if they are, so that's why we need to tap into that area as well. Why interdisciplinary research group? So with the case studies that have been highlighted so far, healthcare, agriculture, climate change effects, and then we have a lot of surveillance. We have students who are here to demonstrate their work on surveillance and what AI can do. Computer vision and robotics, that's what we do here at the Faculty of Engineering mostly, and then other things among transportation. So here you can find potential research projects in line with, interdisciplinary research work. So one of the reasons why we need AI or machine learning is that we can automate tasks. We can automate tasks in hospitals, in clinics, agriculture, traffic, all these problems that we have, real-world problems that are surrounding us. So AI can do this work. And all you need is, I think, the planning part is to have a team of experts get together, understand the problems, and then see how best we can gather information. Information gathering is the most challenging problem because we know they say data is a big resource now, but how do you gather information? How do you process it? How do you use it? How do you deploy it? So that still remains a very big challenge that we have. So these are some of the key projects before I discuss one to show you how people are using artificial intelligence in their, in making decisions, in helping communities and cities. This is one big project by Makere Airco. Doing the traffic monitoring, I think the app is already somewhere. So you can have that, that is air quality monitoring. So you can see the air quality in your location and you see, and you're able to know maybe where do you are. On health, that is on malaria diagnostics. This is led by Dr. Nakasi Rose. I think she's a former lecturer here at Busitema. So, and they're also some impactful projects in this line. So you can already see that AI can be used really in our, to help societal problems like that. So there is another key project you could relate to. Currently, there's a lot of work going in, translation, like what you see, that is natural language processing, or what ChatGPT uses, some of those things. So there is a lot of research people are doing. Like in this case, if you visit Sunbird AI, you can see how people are able to translate, for example, text, e.g. from this language, how you can ask, the applications to help you do stuff. So with that said, I'm going to talk about core about the research that we're doing here, the AI lab, Busitema AI lab, which has been part of the ongoing, research project, and with key directions and where we are headed. So in this case, we are trying to see how can we improve crop health using key technologies like spectroscopy, sensing in all this real-time monitoring. So just a bit of a background, if you know how the agriculture system looks like here, it's something that is not well connected at some extent, but we have so many challenges to do with crop disease, crop monitoring, how, and over time, we know a smallholder farmer, all farmers have been affected in a way, one way or the other, coupled with climate change effects and all that. So this reduces a lot to do with productivity. And so in the long run, prices go high, not only one crop that we are seeing here, but in all different types of crops, which are also seasonal. So in this project, what we did was to understand the diseases that surround this particular crop, e.g. and other crops. And then we see, can we empower, I talked about data, data gathering. Can we empower our smallholder farmers to give us this information from their different regions? So we worked on a small application, which is already also on a Play Store. You can access it. So these farmers in their regions, they can already take pictures with their smartphones, and they perform some sort of diagnosis to know if the garden is sick or it's not sick. Or they can still use the application to use, to query it, and some of them can already speak English. They can put some, some text there, and they get feedback. Others also trying to work on the translation part. Those who can't speak English but they have problems, maybe with specific languages, can they still interact with the systems? Here we are trying to eliminate the agriculture experts, people who visit different regions, informing these farmers what they need to do with their crops. Of course, they also try to, they give them different breeds of the crops and all these different varieties that would work in their regions. So here, the farmer can already know, with my garden, I can plant this variety, it can grow like this, I can have an estimate of this amount to harvest. So with this application. But why I talked about spectroscopy 1, which is in line actually when the previous presenter was talking, I was seeing a lot of, similarity, much as we're working on a different project. So in this particular tool, we tried to, we developed a tool or an add-on on the smartphone that a farmer can actually sense their plants, and they're able to know that my garden is sick even before the symptoms are visually out. So we worked on this device that is from not very, it's actually it's a difficult concept, but not very difficult concept that we can use. So we use local resource materials, because ideally if you're to get the spectrometer, which is outsourced, which can get off the market, it's about 10,000 USDs. So we are trying to, to go back and say, can we have a locally developed spectrometer that could be, a farmer can get at about 5 to 10 USDs, and they use it for the same purpose. So this is where the idea starts from. So we had these ideas, we had everything that we needed, we built versions of this tool and iterated over and over, and came up, so far we are at a very advanced version of this prototype of this tool. So how did we validate the tool? What did we need to do? So we had to grow plants in a controlled setup. We had to infect them, we had to monitor them over time. That is, over time means about 20 weeks plus, to see if a plant is really new, and you infect it and you see like how your body system works. Maybe malaria enters your body, Day one you could be, the symptoms may not show in the blood, but maybe on the other day. With other institutions. At this point, when we are collecting this data, we have what the system tells you. We have an expert. We have also the biochemical. We take these So at the end of the day, I think I'll try to skip this, but at the end of the day, part of the methodology, we had to to put in a lot of effort to understand how do these features look like, what do we need out of this whole spectrum, what is more relevant, which is somewhere ahead. So we have had our students do this, participate on these projects, and then do the deep learning the professor was talking about here. So I use these methods and then calibrate these tools, and at the end of the day, find some, make some comparison to see if you had this high-end spectrometer of 10,000 and you've locally manufactured your own tool, and you're almost closely rated in the same, accuracy, see 78 versus 98. So you really see there is some correlation. So this graph should really look familiar, but one thing you need to know is, much as you have all this data, you want to learn and understand what is special about this data you're collecting. Do you need everything? Because as you know, it is very difficult to process data, very, very highly, it is very highly computational. You need a lot of resources. Like, for example, the spectral, I'll just talk more technical. I'll talk more technical that the spectral dimensions are very highly dimensional. Like, one data point could have over 3,000 features, but you need over 1 million features to process. So what do you need to do with this data set? So there's a lot to learn. So what you do, we understand the relevance of these features. For example, if you have all these dimensions, is there a particular inference, maybe a particular point on the spectral, on the spectral wave, e.g., that can tell you that my disease is here. So once you know such a thing, it's easy for you to calibrate your tool, that the one you're developing, to say, much as I get all this, I don't need everything to process, to move forward with this data. So that's what we've been studying, and also trying to implement that back onto the device. So this is the point of, I think, of collaboration with other groups that we have here, that once you have a pipeline of your data set, and you have a framework of your data structure, so we can work together and ensure that your data is really well informing the audience. You have more insights within these data sets. So, and besides that, data is a resource. Like we told you, here we have millions of data sets that we've worked on that experiment. So even if you have a whole, you run a whole experiment, but then you don't have setups for how you're going to have your data saved, reused, and also other people use, then it becomes a bit challenging. So one thing is to share protocols for data collection. I think that is very important in data science, and reuse protocols and maybe improve them. So besides that, we're able to meet some communities here in Eastern region and also away. We've been able to interact with different farmers and those who have used our tool, and it gives us some, a lot of hope that really these people need our technologies to work as early as possible. So with that, I don't think I had so much to add on, but my talk was meant to open some people's eyes for how best can we take data science and artificial intelligence serious in our research work. So I think I stop here. Thank you.
Highly welcome for Dr. Godliver. Yeah, she was speaking in coded language, so I'm sure many of you might have understood her very well. Any questions? Yes, Dr. Rico.
Thank you, Doc, for nice presentation. Though I missed part of your introduction. When you talk about the spectroscopic data for disease detection, and I see you have put there some UV data, especially in the visible region. But now there's this common problem which we always find of maize about aflatoxin. Now sometimes it is very hard for a farmer to pick this data and take it to the lab. Our analytical process is quite too long. But if we could use your technology of spectroscopic data, where if I can use my phone and get this sample, I know currently you are still concentrating on imaging. I don't know, you have gone to the UV. Now, if you have this data, can we use it for detecting some of these contaminants in the food samples? That I can use my phone device and I just scan through and have this. But now this one also brings for you that the capability of the camera, the type of the the light they're emitting into the sample. Can it be incorporated into that? That's what I'm more interested in knowing. Thank you.
Thank you very much. So, yes, you realize at the farmer level, maybe their camera, phone, or the type of phones they have is not really good. So that's why we're trying to have a specialized, sensor that could be used, as an alternative for their cameras. But to some extent, this technology can be advanced to work like an application on your camera that you can already scan. Use it to scan. Once you have the application on your phone, you can already scan your sample already. But the nature of the problem that you have, aging maize and what, this is our focus actually. We want to have a device that can be multi-purpose to have a sensing capability to look at these, these features. Just like how you got the X-ray, machine, or you go to the hospital. You have like X-ray pass through here, could be here, could be anywhere. So at the end of the day, you pick up that the doctors are able to analyze those different images. So we should also be able to pick different, problems within a given sample.
Thank you. Yes. Yes, good afternoon. Yes, my name is Wako Shadidis. I'm a student and researcher from Islamic University in Uganda. Yes, for me, what I want to ask is like, how can I get to collaborate with you into AI, data science, because we'd like to get in touch with professionals to learn more, and then we can share knowledge and ideas.
Yeah, thank you very much. So we are really open to collaboration, which we are really looking for. You can get in touch with us, me directly or our colleagues here, but we also have a network, a good network of data scientists in the country called Data Science Africa. So you can already tap into that network. Good thing there is a WhatsApp and everywhere, so you always see these different things happening at the national level, Data Science Africa. But at the institutional level, you're really free to come to us and we see how we can help or how we can extend the knowledge to, yes. Thank you.
Yes, thank you so much, Dr. Godliver, for the presentation. Samuel is my name. I have two concerns. Number one, artificial intelligence and machine learning have really become a mainstay. But from even one of our presenters, it is a computer-aided tool, which sometimes require field validation. And the success depends on how much data you have. As the AI group, what strategies do you have to ensure that we have as much data as possible to increase the predictions from this system, if my question is clear in that line? Because it is really very challenging. If you have a very small data set, the accuracy and precision becomes very small. Then the last one, I've met a person, and I'm happy to announce it to you, who wants to design a smart bra. This smart bra to detect what? Cervical breast cancer. Unfortunately, I'm not an AI person, but it's too much and they have the funding, by the way. I don't know whether it is possible. What is your say on that?
Thank you very much. So I was with the first one. That's why I asked that we need a lot of collaboration within faculties and departments, because there are always solutions. One, There are models that have already been learned on certain problems, what we call like transfer learning. Once you have like a small data set, but then you realize that there is something that was already studied in similar to what you're trying to do. This can be achievable. This can be done using transfer learning of those models, how they work. Experts know how that works. But still, depending on the project or what, you can still get more data. But I think this comes with how you can collaborate with different institutions, having MOUs. Like at the moment, we are struggling really to get into some health data that we need. But I guess with time or when we have policies, we're working well, it can make the system very easy for us. Regarding the smart bra, I think I can't comment so much because I don't know much how their project they're doing it, but there is work on breast cancers and all these cancers. If there's a solution for that, yes, that would be a very good thing. The only thing is the effects and and if they have studied all that and it is safe for people to use, then why not? Because we need really solutions for these problems. Thank you.
I just wanted to add on rejoin. I think SB has just said that he has funding. I think we have a PhD program in materials engineering. So, and the deputy dean is here. So I think that's a good project for materials engineering. And there is a lot of work actually done in materials in terms of smart sensing. So basically, I think that can fit in there. But since you've brought the issue of bra, that would be good stuff collecting data. Especially, he has just told me also he's thinking of about a smart pajama or something like that. So, but besides that, I think it's a good project for materials engineering. And that's what you've just said, the interconnectivity which we should thrive on, interdisciplinary research will take us very far if we leverage on that. And sometime back, actually, Faculty of Health Science gave us a project of developing a smart carry-on bag for, the kangaroo babies, what do you call it? Kangaroo sack, that's care. And they say that we should develop something like that. But I don't know why the PTI department has not picked it up yet. But they say it's something which they need, whereby it has sensors in it, and it's able to tell the mother whether the baby is okay. But right now we use rudimentary methods, and maybe just checking on the baby whether it is fine. And that's something which we can work on. Faculty of Engineering, there are lots of projects which Faculty of Science can throw at us. I think we should leverage on that. Thank you very much.
Maybe the last one, now that I'm speaking to the director. I guess, again, maybe I'll talk about a bit of policy, things that we need maybe at the university. Because you control the grants office. E.g., if there is a project that is coming and it's only one people in one unit, how do you support that they get to the other departments? Should be like one of the mandatory things. Then we have students here. At the moment, we're struggling with fourth years, all these other ones, bachelors, and they're all stuck here. But then we have problems at health science. So how are we able to see that we have these students, we say maybe, we have interfaculty policy and all that. Students from health sciences can also work, together with students here to team up. I don't know, I can't solve that, but I'm thinking loud. I don't know. Yes.
Yeah, sure. Thank you very much, Dr. Godliver. A big hand clap to Dr. Godliver. Yeah, I think from her talk, we can all agree that with AI, most of the things can be achieved. Most of the problems can be solved. If breast cancers can be traced at an early stage, then also the prostate can also be managed very fast. Yeah, so we want to appreciate the great work being done by the AI group. And as we have seen from the Bunapric, I so believe that really we have a lot to achieve together through collaboration, partnerships. The gentleman from IU, really we are open. Dr. Godliver is here.
As we head out to lunch, maybe you exchange contacts, and all other players in this research arena. So I'm told the lunch is ready, and I believe that we are all tuned in for it. I want to thank you so much for being a very good audience. I want to thank the presenters who have presented so far. May we clap for them for the good work they have done. And also, all of you have put up questions, comments. Let's keep meditating upon them and interact freely with the presenters, the different research groups, so that as we network, our synergies really can be consolidated to have a significant impact to national and international development. So let's go for lunch, and let's come back here, I think, in the next 40 minutes. Yeah, shall be back. And I've been Ambrose Ashabahewa, your chair for this session, and the next session will be chaired by another person. Thank you very much. Oh, Dr. Rico will chair the next session. Very good. Have a nice lunch. Maybe someone can pray for us? Yeah.
Yeah, someone will pray, but as you go for lunch, and then around evening tea time, there are exhibitions, nice things that you can interest yourself with, so you can move around the tents to see what is being exhibited. Yeah, thank you. And so for the lunch, Professor, you can pray.
All right, let's humble ourselves and we pray for the lunch. Father in heaven, we thank you for today, and we thank you for the blessings you have given us. We thank you for what has been prepared. We ask you that you bless it, that it may nourish our bodies and mind. In Jesus' name I pray, amen.
To start this program at 2 o'clock, and right now we are talking of 4:30. But I'm a person who believes in a crash program. We are going to crash this program, and we make sure that within 1 hour or 1.5, we are done with this session. So the first session of this evening will be led by Dr. Ndema Moses, who will be presenting to us about Trichoderma, diversity in soil. And he is going to educate us how Trichoderma probably is both beneficial and dangerous. And I would therefore advise that those who are coming, if in the program we have given you 20 minutes, if you can do for me 10 minutes, I will be grateful. So as the ICT organizes to power up the system, Dr. Ndema is a well-known researcher in chemistry. He's a senior lecturer in the Department of Chemistry, Busitema University. He has done extensive research in his area of specialization, which is in the natural product for human benefit, and therefore I'm privileged to present to you Dr. Ndema to discuss with us some important metabolites. It could be quite hard, but just know that he's doing it for humanity. Dr. Ndema, you are welcome, and we would be ready. You have 10 minutes. Thank you.
Yeah, thank you so much, Richard. And yeah, good afternoon, everyone. Yeah, so this is part of work that was facilitated or sponsored by Busitema University Research Fund. So we call it normally BURIF, Busitema University Research and Innovation Fund. So we basically decided to look at Trichoderma diversity in soils in eastern Uganda. And then being from chemistry background, my interest was what secondary metabolites do they produce. So when I say secondary metabolites, they're basically chemicals, or let's call them as molecules that these organisms produce. Okay, I hope. Okay, so the motivation for this work. This is the part of the country that we come from, and this country is divided into about 9 agroecological zones. And just coming from food, this is usually my interesting part to talk about. So I just hope that we eat food that is not contaminated with aflatoxins. And so in these 9 agroecological zones, a lot of farming goes on. And what is interesting, or what is disheartening about this is that it's well known that food coming from a number of these agroecological zones is contaminated with aflatoxins. And so this is a big worry to us, because aflatoxins are known to be carcinogenic molecules, and therefore we could actually concentrate these aflatoxins in our bodies and then eventually suffer cancer. And then that alone, if we simply look at it, the levels of aflatoxins in these regions, particularly, for example, in the Busoga farming systems, and also in the southwestern highlands, it's far way higher than what is recommended by World Health Organization. And so based on that, we also know aflatoxin contamination not only affects our health, but also it affects our economy. So Uganda got a ban on their maize export just because it was known that our maize is contaminated by aflatoxins. And so this was the motivation for this work. So our question was, how can we be able to have an innovation that is able to decrease levels of aflatoxins in our harvest? And so when we talk about aflatoxins, we basically imagine spoiled groundnuts or spoiled maize that looks like that. And so it is basically a chemical produced by some fungus called aspergillus. And this fungus produces this kind of chemical, which has interesting rings here, a furan ring, a coumarin ring, and then some lactone ring there. And so when that molecule binds to DNA, and then it can cause malformation. And so this malformation eventually can result into cancer. And it's estimated that about 3,700 cases of liver cancer are actually associated to aflatoxins. And we lose about $577 in economic losses due to aflatoxins. And then for Uganda alone, for Uganda particularly, Uganda lost about $121 million in agro revenue just because of ban of Ugandan maize to be exported to Kenya. And so when you look at the current strategies to avert the danger from aflatoxins, these strategies include removal. They include UV treatment, heat treatment, but the techniques are quite expensive and not easily adaptable by the ordinary farmer. So then we thought, how can we be able to support the farmers to be able to control aflatoxins? So a number of researchers recommend biocontrol, and this is where the idea of Trichoderma diversity in eastern Uganda came about. So when you talk about Trichoderma, it's basically a filamentous fungus that basically is opportunistic, so it can be able to grow on anything in our field. And also it parasitizes on other fungi, particularly aflatoxin-producing aspergillus. And so this was a good motivation for us. We thought if we can be able to identify robust Trichoderma species, we can be able to use this as a biocontrol agent to reduce aflatoxin contamination of our crops, particularly cereals and legumes. So these are basically pictures that show how aflatoxin grows, and this is an interesting picture we took in the lab trying to show how aflatoxin grows with, this was fusarium, and you can imagine how this aflatoxin confines this fusarium, and in this way it actually parasitizes on this fusarium, and so this fusarium will not grow anymore. And so based on that, we also looked in the market. We found that in Asia, there are so many Trichoderma products in the market. And the beauty with this is that Trichoderma thrive in particular agroecological zones. So that means we cannot actually import these products from Asia and actually use them here. That means we need to look for our own solution from our soils so that we identify robust varieties that can be able to parasitize on aflatoxin producing fungus. So this is basically the concept of our research. So to get Trichoderma species, grow them up, and then after growing them up, make extracts or simply use it as it is, and then come up with a bioproduct that can be used either as a spray or that can be used in the soil or that can be used to coat seeds. So if you visit our stall outside there, you'll find 3 products, one for foliar spray, one that you can put in the soil, and the other one for seed coating. So these are products that have come out from this kind of research. So our interest was to develop a microbiocide that can be able to reduce levels of aflatoxins. And so in eastern Uganda, we then took a survey and moved into different districts and isolated fungi, and our interest was on basically a Trichoderma. And so we've done a lot of molecular characterization, and this is just a phylogram that shows the fungal isolates from eastern Uganda. And somebody will say, I'm from a chemistry background, but how are we able to do this? But I think I have passion for biology as well. And so, yeah, we identified these different clades of fungi. But importantly, in eastern Uganda, we realized that now a number of the Trichoderma actually belong to the Longibrachiatum clade. And so most of these are varieties of Longibrachiatum. But also we're able to identify Trichoderma hasianum and then Trichoderma coningiopsis. And so these are typical Trichoderma that have been shown to inhibit aspergillus growth. Okay, I don't know what has happened. And so based on that, the next question was, do these fungi actually, do our Trichoderma actually inhibit aspergillus? So what we did was, we did what we call co-culture. So we played our Trichoderma alongside aspergillus. And as you can already see, I don't know. Okay, as you can see in these plates, could this be from down? Yeah, so as you see from these plates here, you can already see this. We co-plated the Trichoderma with aspergillus, but it actually inhibits aspergillus growth. And similar to this, and then similar to this, and this one here is the other picture which shows this Trichoderma inhibits growth of fusarium. So from this now we are confident that the isolates that we have are able to inhibit other fungi, but most importantly, aflatoxin producing Aspergillus flavus. So then from the chemistry background, my question was, what is it that is in this Trichoderma that is able to inhibit these other fungi? And that's when then the chemistry bit of it came in me to look into the metabolites that this Trichoderma produces. And so we developed cultures, and then from these cultures, we, of course, did a bit of genomics. This is an aspect that ideally we've not explored that part, but it's one of the tools that we can actually use But apart from that, we have taken this other route of mass spectrometry, so to do what we call metabolomic analysis, and then from that metabolomic analysis, we're able to annotate the secondary metabolites that are produced by this Trichoderma. And so based on that, I'll just show you. So what we do is we do spectromatching. So the AI team may possibly understand this, and this is another interesting area of artificial intelligence. So if you have two molecules that are similar in structure and vary in terms of the functional groups, in mass spectrometry, they usually have kind of similar fragmentation pattern. So you can be able to use the fragmentation pattern to match these compounds with those which are actually known. And in this way, what is not known, you can be able to infer it. So based on that kind of spectral matching, then we did this in a global natural products social molecular networking, a platform. And so we can be able to cluster the different molecules depending on their fragmentation pattern. And so similar molecules, because of similarity in their fragmentation pattern, they are clustered together. So as we can see here, we are able to identify classes of compounds in this big network of secondary metabolites produced by Trichoderma. And so then we go into details of this. These are fatty acids, those are peptides, these are phospholipids, and these are some cyclopeptides. And so we're able to annotate some of these compounds represented by a number of these dots. Just to show a simple example here. So when we zoomed into the cluster of phospholipids, we're able to identify basically phospholipids belonging to phosphatidyl choline. And these are typical molecules that have been illustrated to be produced by a Trichoderma, molecules that actually help it to dissolve other fungi. So we're able to annotate some of these molecules, and then by simply doing spectral matching, then we are actually able to annotate many of these. I've not put all the structures here. And then, apart from that, when we zoomed into the cluster of peptides, we're able to interestingly identify a number of peptides that are produced by these fungi. And these are typically cyclic fungi, cyclic peptides. And these cyclic peptides tickle the mind. What is their role? I think these are the peptides that this fungi uses to inhibit the other fungi, particularly aspergillus. But also when we look at peptides, they possibly have other uses. And so I think there's another presentation that may come after this, which will talk about the role of these peptides in actually treating some of the tropical diseases. So I will leave that for the next presentation. And then also, when we looked into the other clusters, cluster G, we also realized they are basically peptides. These are pyroglutamine, phenylalanine. And then so we're able to exactly identify a number of these peptides produced. So the same technique that we use, so we're able to, my interest now went into these peptides because from my previous work, we realized that peptides are actually changing the landscape in drug discovery. And so I got more interested into looking at these peptides. That's why I'm showing you examples more of the peptides. But the other molecules are also very important. For example, now I have a student, I think he's registered in Makerere University, who is interested in looking at these molecules which can actually be used to develop drug delivery systems. So he's now currently investigating these molecules, but also, of course, one of our students will present about these peptides and their biological roles. And so looking at the area of metabolites that these Trichoderma produce, then the next question was now, can we be able to tell whether they can be able to inhibit, can be able to reduce the levels of aflatoxins. Now that will be another presentation for the other group. We encourage a collaboration. There's that far that I can go, but I need another person to take up from there. So the products that we produced were sent to the Faculty of Agriculture, where these products have been tried on station and also in farmer fields to actually see if they can be able to promote plant growth and also reduce levels of aflatoxins. But for the levels of aflatoxins, we still have a funding gap. The samples are collected, stored in the freezer, but we still need some funding to analyze levels of aflatoxins in the samples that we have. But so far, the products have very interesting ability to actually enhance plant growth. And so we will wait to listen to this in the next presentations from my colleagues here. So thank you so much. And I acknowledge Aburi for the financial support to do this project. Thank you.
Thank you, Dr. Andima, for that wonderful presentation. Due to time restriction, I will also restrict the questions, unless there's somebody with a very burning question. Up to Dr. Kello, gentleman behind there. I start with you. Whether.
Thank you very much, Professor, for your very elaborate presentation. I would like to know how the environmental factors of temperature, pH, moisture, among others, affect the diversity of Trichoderma. Thank you.
Yeah, okay, that's an interesting question. It's more ecological. I hope I can be able to answer it. Yeah, okay, so the reason why some fungi will thrive in one region and do not thrive in the other possibly explains that. And so these fungi tend to adapt to particular environmental conditions. So if you take one from here and put it in another agroecological zone, it may not perform very well. And so definitely temperature, the pH, and the other environmental factors definitely affect the distribution of these fungi. And that's why you're able to isolate particular species in one agroecological zone, and then you are able to isolate other species in another agroecological zone. Yeah, so definitely temperature affects their distribution. And how it does it, that requires possibly further investigation to see how it really does it. But possibly that can be for an ecologist to look into details. Yeah, thank you.
Thank you. Thank you for the nice presentation, Dr. Ndema Moses. It is interesting that Trichoderma is producing a lot of macromolecules and peptides. But you seem to be focusing on one group of molecules at a time and looking at the effects. Is there a possibility or any small chance that the inhibitory effects of these molecules could be synergistic? Could there be synergy between phospholipids, fatty acids, and peptides working hand in hand or together to inhibit the aspergillus, the aflatoxin fungus?
Yeah, so it is possible that yes, these molecules work in synergy. So what we know about nature is that nature produces these molecules for protection sometimes. For plants, whatever molecules they produce is basically for their survival. So all these molecules have a function in the fungus. But then it waits to be deciphered whether it is the peptides or the phospholipids which are responsible for the inhibitory activity. This needs to be investigated further. But now, at the moment, what we only know is that they produce a wide array of molecules which possibly are responsible for their inhibitory activity against the other pathogenic fungi. Yeah, but also Its inhibitory mechanism has been well studied. It does what we call mycoparasitism, so kind of it tries to deprive the other fungus of nutrients that has been established, but also the ability to produce molecules that inhibit the other fungus has also been established. So what is not very clear is which molecules are responsible for the inhibitory activity. But so this already provides insight into the kind of molecules that this Trichoderma species, particularly the one we have isolated from eastern Uganda, produces. And we can now go into further understanding what are the roles of these different metabolites. Yeah. Yes, because the fungus is the one that produces them, it produces all of them. So in the biofertilizer, yes, so its biofertilizer property is because of some acids that it produces. I didn't show the structures here. These acids help to dissolve the minerals already in the soil, and then makes it bioavailable to the plant. Yeah, thank you.
Sorry, Dr. Ndima, I will cut you short.
Okay.
We don't have privilege of time, and I want to thank you for the wonderful presentation. I had here my comments, but I will reserve it, if you could reserve it for another session. I was just wondering whether the metabolite which the Trichoderma produces may not be rather harmful, and also the metabolite you have profiled, the fatty acids and peptide, if they're not just a basic primary metabolites. But don't answer them now. I would invite the next presenter. It is something for you to think about. I would invite Marcy Chepgira to give us her presentation. Again, please you decode those terminology. Chepgira, do you have her presentation? We don't have people online. Must say you have 10 minutes, but the less time you use it is better.
My name is Trichoderma. I've just come to proceed from where Dr. Ndima has stopped. The topic I've come to talk about is about HPLC Q-TOF coupled with HPLC Q-TOF mass spectrometry, based metabolites profiling, network pharmacology, molecular docking studies, to interpret the mechanisms of Trichoderma peptides in the treatment of malaria. So this is one of the ongoing projects under TRICOS. TRICOS is being chaired by Dr. Ndima Moses as the PI. So what was our target in this topic? This topic is, there are very many authors behind it who are contributing a lot to this topic. So our target was to talk about malaria. So as we all know that malaria is one of the life-threatening tropical disease that is caused by a parasite. And this parasite is most especially the Plasmodium falciparum that is transmitted to humans through the bite of an infected female Anopheles mosquito. So why have we interested ourselves to talk about malaria? From the current studies, researchers have reported that malaria is causing an economic burden to our families, whereby it is killing every child. It's killing a child under the age of 5 years every minute. And this makes malaria to be considered as an urgent public health priority because of the economic burdens that are being brought into our families due to frequent sickness. As we all know that when you are sick of malaria, you can get very many consequences. You can have headache, vomiting, and it can limit you from going to work, and therefore it will bring your work what? It will bring your daily activities down. So, and this is particularly in sub-Saharan Africa. So, but malaria is curable and preventable, and we all know some of the preventable measures. Sleeping under a treated mosquito net. People have also tried to use some of the indoor spraying like mosquito repellents in order to make sure that they reduce the spread of malaria. But even if you have reduced the spread of malaria, not all of us sleep under mosquito nets. You can try your best to sleep under mosquito net, but someone who doesn't sleep under a mosquito net, but he or she has been bited by an infected female anopheles mosquito can still transmit the same disease to the person who is trying a lot to prevent the disease. But there are current cracks that have shown activity against the most alarming malaria parasite, that is Plasmodium falciparum. And these are the ACTs-based combination therapies, but the recent literature have reported that these ACTs have shown some resistance against the most complicated malaria parasite, that is the Plasmodium falciparum, and therefore there is need to come up with new remedies to make sure that we remove these conditions of malaria from our bodies. And now our new innovation is based on Trichoderma. As Dr. Ndima elaborated very well, Trichoderma is a genus which is found in soil and it can be cultured. And this Trichoderma was cultured in eastern Uganda during the process when we were carrying out our project activities of Trichoderma. And this Trichoderma genus produce short peptides, and these short peptides produce secondary metabolites, including short peptides called the peptide balls. And these peptide balls have shown a very good anti-Plasmodium activity and can inhibit the Plasmodium falciparum due to the current studies. So this is our Trichoderma, as it was also shown by Dr. Ndima. This Trichoderma, the soils that this Trichoderma is from the soils in eastern Uganda, including Karamoja. So, what was our approach when we were carrying out this thing? When we were carrying out this project, we had 3 steps. The first one was metabolomics analysis. During metabolomics analysis, we had to use HPLC Q-TOF. HPLC Q-TOF is high-performance liquid chromatography coupled with quadruple time of light mass spectrometry. There are very many steps that you have to follow. There are like 3 before you conclude that you have your secondary metabolites. So during the metabolomics analysis, we had to identify 24 peptides from our Trichoderma species that showed some activity in the malaria genes. But how did we know that they were showing some activity against the malaria genes? We had to go for network pharmacology analysis, which is now not a new term to you. So in network pharmacology helps you to analyze how the bioactive compounds in your biological samples, for this case now we are considering Trichoderma, how they can how they can interact with the proteins that you are aiming at. For this case, we were aiming at malaria. So we had to do the Swiss target prediction, where we had to get, first of all, the targets of our short peptides. And those targets of the short peptides, we used the Swiss target prediction. We also looked at the targets of the malaria genes. We used OMIM, DisGenet, and GeneCards. And after getting all of them, we mapped the targets of the malaria and the targets of our peptides, which gave us a clue that our peptides can Our peptides have some interaction with the genes of malaria. So those peptides were further analyzed using another database called strings. The aim of strings was to get different networks. We had to get the protein-protein interaction. We also got the gene function, and that aim was to come up with the hub genes. The hub genes, these are genes that can bind with very many other genes. And the main active peptides, those are the main active peptides that we got. So from there, those hub genes, there were very many. We had again to go to cytoscape, where we ranked them using different methods, which I will show you in the results. So after getting our hub genes that were helping us to get a deeper understanding on how our genes were interacting with the targets of malaria, we went further to do molecular docking, which is not also a new word. In molecular docking, it helps us to predict how the targets and the genes of malaria also gives us the targets of malaria also gives us how they are binding, and it also shows us the mechanism of action of our genes and the peptides, basing on their binding energies, which we are going to see in the results. So this is also this one is showing us the metabolomics analysis, which Dr. Andim also showed how we clustered our peptides. So those peptides we considered, there are very many, but we were considering those that will show some small similarity, but they could just differ in either one or two functional groups. So this is also a protein annotation. This is not clearly seen, but this is a protein. It's a glycoprotein. It's a cyclic protein that is a cycloprotein, which shows very many. Showing us very many networks, and these were analyzed using TNPS library, natural product, social network, pharmacology. The same, those are our peptides that we got. As you can see, the red ones were the ones that we predicted. Those are the ones that were shown in the metabolomics analysis to have shown a very good activity against the antiplasmodium. Plasmodium falciparum, but we still need to do further investigation. But these ones that are black in color, and it shows that our Trichoderma still has a lot of peptides that needs to be further isolated, but they are not yet known. So these are our 24 peptides that we docked. So these are the results from the Swiss target prediction. As you can see, this one is called the boiled egg. It shows how these genes can be absorbed in the brain barriers and also in the gastrointestines. So the ones in the yellow, the egg yolk, are the ones that can permeate through the blood-brain barriers. Then the ones in the white part are the ones that can be absorbed in the gastrointestinal during the process of gastrointestinal. So this is the protein-protein interaction network, which showed us the genes that can interact with the genes of the malaria, and those ones also that interacted with the genes with the targets. So this is how we identified our best 10 targets. We applied the maximum neighborhood component, then the degree of nodes, then the maximum click central lead. And this Venn diagram is we mapped these three and we ended up coming with the best 10 genes that could be having the potential activity against the malaria parasite. And those genes they are there, as you can see, they are 10, starting from the interleukin 1B protein. So these genes have showed nice functions for their importance are highlighted. You can see the first one is associated with severe malaria, the first two. Then the last one regulates the transmission of malaria from the mother to the fetus, which means we can still do more investigation to come up with another remedy for malaria. So those are the molecular docking analysis. We compared the target. The target is our protein. Then we modified the target into a 3D structure. During this process, we applied the protein data bank or protein database. And the ligands, as you have seen, the first one is cloquinine and then artemisinin. Those are some of the current drugs for malaria which are in the market. And these are our proteins now, and the inhibitor is there. So we compared based on their binding energies. As you can see, the binding energies for the current drugs of malaria, it is ranging from -12 up to -18. Then for our peptides from Trichoderma, we have the highest is -22, and the least is -16. Together with their inhibitor, we have not included the inhibitor is there. So the inhibitor is showing a -18.5, which means we can just modify these structures of our peptides by playing with the functional groups to make sure that we get a better binding energy, the more negative binding energy, because the more negative the binding energy is, it shows the drug is working against that parasite. So those are more targets that we were there. Out of the 10, they are the ones I have shown. Those are the molecular docking studies. Then the conclusion now it was about these peptides. Since these peptides are showing a very good anti-malarial activity based on the in silico studies, we now say there is need to make sure that we do more analysis in this network, in this work to come up with a new remedy that can help to overcome the resistance shown by Plasmodium parasparum, which has shown resistance in the current ACT. So there is need to do more validation in vitro studies. Thank you so much for listening.
Thank you. Thank you. I thank you for that presentation. Mercy, we would wish to give you more time and explain for us those docking, molecule, because malaria is our problem. You're innovating a new technology. I will open now the session to the audience. If you have any query for Mercy, it is welcome. I will again restrict it to 2 so that we manage our time. Yes, Dr. Kello.
Yes, Mercy, thank you for the presentation. A continuation from where Dr. Ndeba ended. Now, you mentioned that in order to reduce the binding energies, you may have to modify the functional groups of the peptides. Remember, these are peptides produced by the Trichoderma. If you have to modify the functional groups, would that alter the properties of the peptide? 1, 2. Can it now be synthetic? Can't you just synthesize the peptides instead of going for peptides produced by Trichoderma? Thank you.
Thank you so much, Dr. Okello. Yeah, when you alter their structure, it can just, for sure you can, like when you're altering the structure, you may see that some of these peptides might be differing from either one functional group. But our target in this project is to make sure that we isolate the accurate peptides that will show the potential activity for malaria. So altering can cause some, it can change the properties to a small extent.
Thank you, Mercy. I have a comment which you don't need to answer. As you go down, I will be inviting the next person. Now, you are innovating a new technology for malaria management. You are using peptide. And do you know any drug which, for anti-malarial, which are peptide derived? Another thing which would follow there, peptides are like proteins. When it reaches our stomach, the enzymes, they get happy and they start digesting it straight away. What would be the method of administering your drug? Have you considered that? As I said, these are questions which you don't need to answer them. As you think about the drug, think about the dosage. And also when they reach in the blood, if you are going to pass it through the blood, don't you think they will be reacting with the blood proteins and others? So if it is a target to a parasite, don't you think they can bind with they seem to be having a high binding affinity. Don't you think they will bind with other receptor in our own body? Please don't answer them. At this juncture, please help me to thank Mercy for this wonderful presentation. And at this juncture, we want to move away from this medicine things. We are bringing in technology now. Please help me and welcome Dr. Kamoga. He's going to tell us the technology of producing filter papers. All of us at a certain point, we use the filter papers. I was wondering why not teach wood papers, which we use every day? Why do you go to filter papers? But those are the questions you are going to answer as you are making your presentation. Dr. Kamoga is a senior researcher in the Department of Chemistry at Busitema University. He has a lot of technology in palm and paper. Please, you are welcome. Please take the floor. Your presentation will be loading shortly. There's a microphone there. Yes.
Thank you, Chair of the session. Dear directors, deans, heads of departments, all researchers, ladies and gentlemen, by the name of Kamoga, or Dr. Kamoga Omar Wako Mohammed. So I would like to take you to the chemistry which is near the market, because others were taking in that had the chemistry, but this one is very close to the market. Today I would like to present to you the manufacture of filter papers from Cypapogonus canodus grass for lab use. I've been researching for this for a long time, and I've been researching with other colleagues of mine. I have Dr. Richard Kifuko and Olowo Moses from biology department. We know now our Uganda is at its apex of exploiting and looking for innovations from scientists and such that we can do value addition to our natural resources as to overcome some of the trade imbalances and do import substitution. So our dear President of Uganda is now emphasizing more of science such that we can overcome, we can do we can do local production, and such that we can overcome these trade imbalances in terms of imports and exports, where the exports tend to be less than the imports. Okay? In this case, there is already a campaign, national campaign, to see that we emphasize local manufacturing of some essential materials or items that are very essential to our life. For example, with paper and the paper products, like filter papers. Filter papers are essential in that they are used in research institutions, in our academic institutions. I think maybe if we did not study from new curriculum, the old curriculum, everybody must know that part of chemistry where they are taught filter and keep the filtrate and the residues. Okay, so this is where that product is very, very important, and more in researches, in research labs where we have been able to use this. So producing such items like this will tend to save the national foreign exchange and also correct the trade imbalances that exist. So some materials which exist in the midst us, like Cyphogonous canudas, which we know in our local language, like Uganda's tete, or in the West called mutete. This is a very fibrous agricultural residue materials. Sometimes it is a residue due to the fact that they normally use it to get essential oils that deals with in medicine. So that material is normally wasted there, but this normally to contain cellulose that can be used to make a paper and make a paper products such as filter papers. Okay, the Cyphogonous here has fibers, but in making these filter papers, we can reinforce those fibers or the pulp with those recycled from waste paper and also from wood shavings. So if we combine those, we can get a paper that fits to use as filter papers. Making paper from such materials saves us or becomes the environmentally friendly method due to the fact that most papers are made from wood. But if we can make paper from grasses and just waste paper, as well as these shavings from carpentry, we try to save the environment by cutting trees for paper. So this research results I'm going to give as a result of trying to identify the technical and economic viability of making paper from these materials, such that we save the environment. So next. Yeah, such problem. So the research team has been trying to explore the national abilities of local manufacturing paper and paper products, such as filter papers, from these waste materials, such as agricultural waste, waste paper from our compounds, and as well as this from such that we can save the government from the foreign exchange that has to be put to import such items like filter papers, which we can make locally here. So some of these materials out there, they tend to be a problem. So waste paper is normally littered in institutional compounds and also in business centers. This material can be collected and then recycled. So also these agricultural wastes, some of these Cyphogonous or mutete are normally cleared around and just wasted by burning it, whereas it has cellulose that can be transformed into paper and some paper products such as filter papers. So producing this would tend to solve the environment and it is still environmentally friendly process. So our goals here, our goal was to produce low-cost filter paper from environmentally friendly materials such as these agricultural crop residues, wood sheaves, and waste paper. So our major objective here is to see that was to evaluate the economic and technical viability of using this agricultural crop residue, some wood sheaves, and also waste paper to produce the filter paper. So in this research, we had first to define the chemical composition of cyanoconoids and also to extract the pulp, which is a mixture of fibers that can be pressed to get the paper and then transform that paper into materials such as filter papers that can be used. Also, we had to see how we can easily mold this pulp into paper and eventually transform paper into filter paper. You cannot get filter paper until you have paper. Then eventually we had also to do, for economic purposes, to evaluate the production turnover. So the outcome of the research, we have seen that we have put on market the brand filter paper. And also we have now the technical and economic results which shows the viability of making filter papers from these materials. The process of making paper and filter paper is very simple. But here you start in the field, you can do field evaluation, which we did. Then you collect the materials, you prepare the materials. The materials, normally this type of coconut is a long grass. You have to size it, to break it into small parts or small pieces, such that you wash them and even dry them. Then you digest using active chemicals and water. So from there, that digestion involves the freeing of the fibers to get the pulp. Then for that pulp you have got, you disintegrate it. You break it and it becomes free fibers. Then free fibers, you can filter off the bigger parts or the unbroken parts. Then you have that material or that fibers which can filter to remove the wastewater, bleach it, dry, blend the cereal. That involves adding binders to bind these fibers together. Then you have the paper molded, and that paper is the one which you have to cut into the filter paper or cycles. So before you make the paper, you have to study the raw material. So in this case, the major raw material was Cyanoconoids canoides. So here you have to determine some of the characteristics that are associated with good materials for making the paper, such as they have the whole cellulose. You see that in green are the results of our material. So they are referenced with this other material down here in the yellow, which include rice straw, sunflower, pinus or pine, and then eucalyptus down there. So we see that the property of our Cyanoconoids canoides are very, very closer to those of wood, which are the major sources of pulp for paper. So the whole cellulose is good enough, the lignin is less enough. Then we have other insolubles. We have the alcohol benzene solubles, they are less. Ash content is less. Then you have the alpha cellulose, that is alpha C. Those are the tough fibers that are good for paper making. You can see that still in good range. Then these other insolubles, in water, cold water, hot water, they are a bit less. So that makes it a good material for paper making.
So we have the process in the pictures. So we have here, we are loading Saprophogonous canudas from the garden. Then we have the digested materials there, which are dark brown. So we can go down to see the process. So we disintegrated the brown material and bleached. Now we have the white pulp that are pressed. At the moment, in our workshop there, we do things manually. So even we make this paper, handmade paper. So this is our mold, and that is our cutter for the cycle, or the filter paper. So we have the samples of filter papers, and we have branded our filter paper there. Let's go down. Yes, we have tried to compare the filter papers we were able to make with those of already on the market. On the market, there is a filter paper which commonly used is called Whiteman. We branded ours as Whiteman. So we have brand 4A and 4B. Huh? We have brand 4A and 4B, that is ours. Okay? So 4A is made with the reinforced wood shelves. Then 4B is reinforced with waste paper. So you see that the grammage is that one there, in relation with this, the thickness. So most important is the erosion time. So when the time is short, that means the liquid goes through the paper very fast. So we have to have intermediate rate at which the liquid or the filtrate goes through the paper. So we have to have a minimum time. So we have the medium, so that takes some time, and we have those which goes through very fast, very slowly. We did not present that. So I presented in reference to the 3 brands of Whiteman. Whiteman 1, Whiteman 3, and 4. Okay? So now I come to the economic evaluation. So you can see, we took a basis of 1 ton of Symposium, which can give us about 320 packets of filter papers. So here we have the cost, which include the raw material itself. You buy it, you buy the chemical that can bleach, water, power, electricity, labor, and packing. We said that for each one pack, it can cost about 9,500. And if on the market, you can sell it at 18,000. So for each pack, you are likely to get a profit of about 8,500. And for the whole ton, we have the cost. We have a cost in dollars, if we are interested in dollars, and we have cost in the shillings. So for 1 ton, you can get a return of about 2.72 millions per ton. If you have already had your machinery and the market is there. So in that case, if we continue producing, I think it will be beneficial. So conclusion, both technical and economic evaluation suggests the production of filter paper from Symposium when reinforced with either the wood pulp from those shavings, or from waste paper as feasible with good sales return. So in this case, if you install your machinery there and you have the market there, so you never go wrong in producing filter papers out of Symposium and some waste materials. For our research, we have the strengths and the challenges.
So, Doc, you summarize the time.
Okay, the strengths is that we, human resources, we are there, and the technology, the materials are available, and some infrastructure is there. Challenges that we still lack machines. We use tools. So when you use tools, you cannot meet the production capacity, therefore it has to be short. and also we still have small funds, which is not enough. So if we are to go to the next level, we need a small line that which could be light industry, and the last time, as for the cost, it can go to install all that charges, could be about $1.2 million required. So we need the big funding, either from the university or from the government, such that we can move to another level. So first I will acknowledge the help from BRIEF, from Busitema University, that is such fund, also the Faculty of Science that has hosted the project, and all members that have participated in this search. Thank you very much.
Thank you very much, Doctor. Let us give him a stand. Really, why should we import filter paper? Bwana Director. And Dr. Kamoga, you have a number of questions which people want to ask. And I also have one question. Would you put there your mega funds for this filter paper?
Thank you.
You can, let me take the two, then you respond at once. Yes, I may not be able to reach it with the microphone in time, but if you can speak loud, please go ahead.
Thank you, Chair, and thank you, Dr. Kamoga, for that presentation. I'm a bit concerned when you got to the point of the name of our innovation, reminded me the phones that we had, or some of the electronics that we had. You had Samsung, and you'd find another product on the market called Swan Swing. Or you would find, you have Nokia, and you find another product, Nodia. So, or Nokia. So don't you think that when our product gets on market, people might perceive it as a fake product of Watman filter paper? Don't you think so? They might think this is a Chinese product and not genuine. Thank you.
Thank you again. Thank you, Doctor, for your very able presentation. Mine is also a very simple one, Doctor. Doctor, I would like to know how you store your extracted cellulose so as to maintain its quality and its original composition. Thank you.
Thank you very much. Maybe I start from the chair. Would I put my funds there? Indeed, if I had funds that can install these machines, I can put my fund there because the return is very interesting as long as you can get the market. Okay? Then the name. So why we put a name similar to or close to those? Commercially, marketing is another major task. If you have where to start, I think you may not need to go far. That I have mine called Kamoga, and they ask where it comes from and whatever. So commercialization, you put something close to that already in the market. Okay? So that is, it starts with the momentum. So that we may not need more advertising and whatever. So people can buy. Our target is buying, not the name. How many can buy and how many profits can get. Okay? Yes. Then how do you store pulp? This pulp, once well separated, is very, very stable. So you can keep it at a temperature above the room temperature, so long as there is that moisture is greater than 20%. Beg pardon, the moisture is less than 20%. Okay? So when it is less than 20%, you can keep that moisture there. The pulp at room temperature. There is no like a mold growing. I've kept it for some time. So I think it's stable.
Thank you, Dr. Kamoga, for this presentation, and you have able answered some of the questions, but we still have a problem with the name. You might think, branding, please put that product on the market so that we should not import filter paper. Now, members, we have sat here since morning, and we have 3 more presentations to listen to. I will request that allow me to only give chance to one presenter, the next presenter, then we have to listen to the keynote speech. These other 2 presentations, we shall squeeze them somehow tomorrow. That is it, because it is really beyond time, and the brain is really deteriorating. And also information which I have, we have evening tea. Please don't leave here when you are not fresh. So after this session, we join behind there where we have lunch, and we refresh ourselves before we leave. Thank you very much, Dr. Kamoga. At this juncture, I will then invite Ms. Namuyomba Angela to make a presentation on I don't know whether your presentation is up here. She's going to give us a presentation on AI. Do you have your presentation? Angela. Yes, an interesting, I couldn't miss this learning human activity sequence to detect crime. At least let me go back with that one at home.
Good afternoon, or good evening, ladies and gentlemen. More than privileged to stand before you to present my research in artificial intelligence. Basically, we are trying to apply artificial intelligence in surveillance. I think my pre-current speaker, Dr. Godliver, has given us quite some insight about artificial intelligence. But now, since we are short of time, I would like to start this presentation with a bit of a scenario. I would like us to first of all imagine, as we were outside there having our lunch, if somebody came in here and maybe took a camera, how would we know who was it? When was it done? I think CCTV, yes. So we have cameras here. But how long would it take us to actually get that information? Yes, we would all know that it was taken during lunch break. So we would have something like an hour or an hour and a half of footage that will have to be reviewed by a certain individual for us to actually get to know who did what. So I want us to imagine if we had a system that could give us that evidence in less than a minute or less than 5 minutes. This is where we are bringing in artificial intelligence into surveillance. As we can see, surveillance cameras have been adopted wide in universities, even on the roads now. Our president installed cameras for us. But for those of you who have not had a chance, or maybe an ordeal that requires you to go to the command center, retrieve that footage, you may not know that it is next to impossible to have that footage. Because one, we are going to be looking at the time that is going to be required to to go through all that footage. 2, it is tedious. Just like I talked about the 1 hour or 1 hour and a half of footage to be reviewed, it takes a lot of time. And to make matters worse, at times it is inefficient because the people we have in those control rooms tend to dictate what they deem criminal and what is not. Then that brings me to the last problem, which is how subjective manual reviewing of surveillance footage is. This is because it hinges so much on your human input. The person in that control room gets to decide whether they can access that footage or not. The person in that control room gets to decide what is a crime and what is not. But imagine if we had a system that would call out a crime once it comes across it. This is one way we can try to leverage AI in the surveillance domain. So the research questions for this study are, can machine learning be leveraged to reduce the time of searching through long hours of footage for scanty evidence of the crime? Number 2, can the dependence on human judgment in retrieving this criminal evidence be minimized? It brings me to what I'm doing about this. I'm using 2 deep learning algorithms to minimize the time we need to review the footage, and also, to some extent, try to eliminate the dependence on human judgment. So one of the models that I'm using is, one of the algorithms that I'm using is object detection. Object detection, in a layman translation, I would say, this helps us to identify objects. Let's say if you've been to the airport, those people don't really need to go through all your bags, but they will scan your bag, and those algorithms embedded in those scanners are able to detect each and everything you have put in your bag. So these algorithms have been used in those more developed countries in facial reconstruction, identifying weapons. You know, these things you find are mysterious back there, and we are all wondering what is there, what is not there. In those countries, these algorithms can simply tell them what is in the bag. So I am using this algorithm together with long short-term memory models. Now, these LSTM models are artificial intelligence models, but they have the capability of storing memory of something they have been trained on. To talk about the data set briefly, I'm using the HR crime data set, and this data set consists of crimes that have been clustered in 13 classes, that is abuse, arrest, assault, burglary, explosions, fighting, road accidents, robbery, shootings, shoplifting, stealing, vandalism. These are crimes that were selected because they are more closer to us. And for this work, we, as I've already said, object detection algorithms are already in use, but they have not been quite adopted in the surveillance domain. So we had to do a comparative study on these deep learning algorithms that are available on the market to try and find out which one performs best with surveillance footage. One of the major challenges with surveillance footage is that most of the times it is not clear, it is dark, there is a lot of noise. That's why we find ourselves, most times, we have police reports not coming out because blurry pictures and what have you. So we found it important to find out how these object detection algorithms perform with surveillance footage. And from our study, we found out that the YOLO version 8 object detection tool outperforms its counterpart, the single shot object detection tool, with a mean average precision of 97%. So from this, we chose to work with the YOLO version 8 object detection tool. Now, what we get from this tool only helps us to detect given surveillance footage. First of all, is there any human in that footage? So the system will only look at frames where there are human beings or human activity. So this helps us to reduce on the time that you would take reviewing footage of this room when we were all out for lunch. So it starts its detection from when an individual entered the room. That is the part of object detection. So for it, it's going to give us your spatial information. Spatial information, I mean where you are in the footage and probably what you're doing. So we are going to take this information and use it to train our LSTM model. Remember the other one I talked about that has a long short-term memory. So we use it to train that model in order to understand what humans are doing, to understand the human activity. So we are only able to do this with enormous amounts of data. For this case, we had a total of around 950 untrimmed videos in the different classes of the crime. So now, from the training of our model, these are our results. Unfortunately, this has been cut out. But on this axis, we would have the true values, like what is true that even a human can see that it's true. And on this axis, we have what was predicted by our model. We have this 0, 1, 2, 3. These are classes or categories of the crime. So for this, we had 11 classes. I will still explain why in the conclusion, because we had 13 from the data set. So this clearly shows you that for class 0, the model was able to correctly classify 123 instances and only misclassified 2. When we look at this diagonal path going down, it shows us what our model got correctly. So for class 0, it means it had 125 entries. It correctly classified 123 and only missed out on 2. So from that confusion matrix, we can clearly see that the model does a good job, because sometimes there are some false positives and false negatives. We had other evaluation metrics, such as the F1 score. This gives us the balance between the precision and recall of the model. And it's our model scored a 0.96, which is indicative of a good performance. Then Matthew's correlation coefficient also helps us to know how close our model's prediction is, how close it is to the actual thing that it is supposed to. Yes. Now, these precision and recall curves you see here are for the 10 classes that we had. We see that our precision tends to 1 for most of the classes, truly a depiction of what we are seeing here. That is just a confirmatory test of these results that we have seen there. So in conclusion, we say that this model is more than capable of helping us get rid of that problem of the long hours and dependence on human judgment. However, just like I said, we had 13 classes in our data set, but we only ended up working with 10. This is because our object detection tools currently need to be further fine-tuned to work better with surveillance footage for some more complex crimes. For example, explosions, arson. It becomes really hard for the tools to detect where the human is in case of a fire outbreak. So we need to further fine-tune that. In future, we also plan to investigate the integration of additional information sources, such as environmental data and social media activity, to further enhance crime prediction capabilities.
Thank you very much. Hi. Okay. Let us first appreciate her. Thank you very much, Angela, for this wonderful presentation. Now I know when my computer disappears, I will be screaming for absence of my object. We have already questions here, and I will go straight away to the questions.
Thank you very much, Angela, for the presentation. Mine is brief. You've talked about the long, short time model, and for object screening, detection. Yes, detection. Now, I'm imagining and trying to think. You gave us a scenario at the start. Someone entered here and picked a laptop and walked away. But as you know, most criminals are also smart. They don't come, naked faced. They hood themselves. So can these models somehow be able to detect the hooded guys? Can we integrate some bit of biometrics to manage that problem? Thank you.
Just by extension to that question, now, will this model be able to work in the dark? Because those are the times people take advantage of dark situations to do bad things. Will it work under those scenarios?
To begin with the previous question, even as I was presenting, I hinted that object detection has been adopted in various disciplines. For example, facial recognition. By that, if we had the systems here, like the way we have our national ID information captured somewhere, if we had those systems here, object detection and machine learning is more than able to reconstruct your face. Even if you're facing backwards, they can detect that it was actually Angela standing there. Yes. Now, to go to Dr. Okello's question about darkness, I think that one goes back to the type of surveillance cameras that we are using. Currently now on the market we have cameras that have, is it called night vision? Yes, as long as an image has been captured. As long as you have an image, because those videos that we see, it is just a compilation of images that technically we call frames. So as long as you have the image of whatever is happening, it is very possible to detect any crime.
Thank you very much, Angela. I think the people who commit crime, we are coming for them with your innovation. We are going to have Uganda free of crime. Thank you. Let us again appreciate Angela as she sits. Today I tried to put on a coat, but my coat I think is undersized. But I will try to stretch it. Please allow me to invite our keynote speaker for the evening, Professor David Olema Kani, to give us a closing remark for today. In his special way, he's going to summarize what people have talked here. He's a senior academic. I can't even tell all his profile, but he's the Dean, Faculty of Science and Education, and he's a senior researcher and a psychologist. And on the other side, he's also a chemist.
Thank you very much. Thank you very much, Dr. Rico. Our boss is here, Director, Graduate Studies, Research and Innovation. Dear colleagues, I'm going to move away from chemistry now and technology. I now want to talk about the whole picture of what has collected us here, what has gathered us here. We've talked about, the theme is resilience and sustainability in STI and academic excellence. I've picked the paradox of this theme. And that is what is going to challenge us as we keep going through this. That computer got tired, but I can talk this through. You will miss a few of the images. Science, technology, and innovation cannot be talked about as it is without talking about education. What is missing in this is education, science, technology, and innovation. And I will take us back to the background of education, the importance of education. And we may sit here and think, we are fully aware of this. We know the importance of education. I just want to remind us of this, and that possibly will take our mind to resilience, sustainability issues that we are talking about here as well. You are here today, and tomorrow you may not be there. And that is a fact of life. And what sustainability are you talking about if there are no people who are coming to sit in your place? If there are no people who are going to take over what you are doing and extending it that far, and how are you going to get them? You're just going to pick them from here and maybe through science allow some people to live forever? It won't be so. So we have to go back to the foundation and emphasize the importance of education. And this is what Mandela said. Education is the most powerful weapon which you can use to change the world. And all these things you've been talking about here, from the black soldier flies and so on and so forth, one would wonder what you are looking for in the rubbish for those flies, and what you want with all these things that you are gathering around. But we've seen the results as were presented here. They're very important to our survival as human beings. And so, that is how important education is. Without it, and I think with our population, the whole world will be crowded and we would have a lot more issues. Or possibly many of us would have died because drugs would not have been there. And so that's how important education is. No country can really develop unless its citizens are educated. These are issues upon which our policies are being pegged. And these are issues upon which governments set themselves to fund. And so education, that is how important it is. Education is the great engine of personal development. It is through education that the son or daughter of a peasant can become a president. The son or daughter of an ordinary person can become a very, very important person. And you are coming from very many different places. Without education, you wouldn't reach here at all. And that is how important education is. And you wouldn't even sit here. We would not have known you. Maybe we would have fought, you know, those old wars, we would have fought them, and possibly you would have been killed and so on and so forth. But education has brought all those down, and that is what it is. So, the Africa Agenda 2060 that is hinged on education, they talk about education and especially science education for transformation of Africa. And this is what it is, and we are here, the products of education, talking a lot of innovations and many more things at the peak there. But the bottom, we seem not to be turning behind to see who is following us and who is going to take up for me. That seems not to be in our minds as we're here. So if we don't think that direction, then what we're doing will be in vain. And that is a reminder that I want to give to us, even when we are in this symposium. And so here, education is crucial, as it is an investment in human capital. The yields are tremendous, and we've seen so many of these things. And so, move on, and we get to see what is happening. The current state of education, regional perspective. We won't take our minds there. And the few of us inside here are feeling very comfortable, but I want to tell you that we are doing very, very badly. Very, very badly. See what is happening here. This is Central Europe. This is Central Europe. The average gross enrollment in higher education, and the likes of us who are gathered here, is over 80%. That is in Central Europe. And in America, this is by 2024. In North America, it is 80%. And when you come to Latin America, it is over 50%. East Asia, it is over 50%. Arab states, it is about 37–8%. Central Asia, it is about 37 or 8%. South and West Asia, it is about 25%. Sub-Saharan Africa, where we are now here, it is below 20%. It is actually 15% in 2024. Now the world average is 40%, and the highest peak for Sub-Saharan Africa is not even near the world average. And that is how we are seated here, and that's how we are doing. Where is the sustainability coming from? And the rest of the world is not waiting for us. How are we going to continue with this? And so this is the big question, and this is what we are getting to now. So the current state of education in Africa, if you want to see a few more figures here, over 1/5, over 20% of children between the age of 6 to 11 are out of school. 1/3, 33%, between the age of 12–14 are out of school. About 60% of youth between the age of 15 and 17 are out of school. What does this tell you about all that we're doing? Those guys, there is more statistics I've not given here. I have it off head. In 2017, 8,800,000 children registered in primary 1. By the end of P7, after sitting PLE, the number that was there was 800,000 only, meaning 8 million dropped off before P7. You can follow your statistics if you've been reading, listening to news when results are being reported. So the 8 million have not died because our population is increasing. They are around and they are available. If you want to know them, walk in the dark in Kampala, along the bypass alone, you will meet them. Many of them are there. And in the corridors, in the cities, and you'll find many of them in many of these townships. 8 million. And when you reach S4, only about between 500 to 600,000 complete S4. Those who complete S6 are, if there are very many now, they are just about 100,000. They're the ones who go to higher education. Meaning over 8,700,000 do not go to higher education. So where is our sustainability? And we need mass production of higher education graduates if we are to develop. If we are not to suffer these diseases that come, they will pick them from the monkeys and don't think you're educated, they will not get you. You buy from them in the market. You will meet them. And those really meet with you as well. And this is where the issue is. And all the beautiful things you may do may be in vain. So innovations to improve education in sub-Saharan Africa have been proposed. Many of them you've heard of, UPE, USE, and so on and so forth. And these will keep appearing even as I keep talking. Can you move the next slide? So the issues here about the innovations are very acute and critical because we need to change the status quo. Gone are the days where you would see an expert say, you know, we are only 3 neurosurgeons in this country. Yes, and then you swell, you move. You should actually be ashamed and sad because you are not immortal. If tomorrow you are not there, there will be 2 left. And to produce one takes a long time. We must change our attitudes and we must change to bring people forward. The population or doctor population ratio by World Health Organization is 1 doctor to how many? About 100. Ours is over 1,000. And we go ahead, doctors that will produce, we claim there are too many, we can't take them through internship. Even if they go, countries that are employing labor also study the countries from which they are getting the labor. If your population or your professionals don't meet the international standard, rather the country does not meet, they will say Uganda has too few doctors, so we cannot take doctors from here. So unless you sneak, you will find yourself there. So these are issues that we have to grapple with. So education in Africa, back, yes. So there is need to prioritize education, and the massification of education is very important. Massification here means we need to have a huge population to educate. And that is the way to go. There's nothing we are going to do as quickly as possible to change the status quo. So we need many of those. Otherwise, I said earlier on, you jokingly you can meet them on the bypass, but that's a very serious situation. In the event, you will see it next year when politics is at high gear. Those people have nothing to lose, not even their lives, but you have everything to lose. And it is within your powers that the status can change. It is the educated who can change this. So all those are innovations that we will talk about if we want to change the status quo. And so now the issue is not science. I insist on this because the sustainability is hinged on education. It is true. As I started from the foundation, basic education, all through that we shall be able to sustain any science, technology, and innovation. We need successors to come through the education system. And so we must mind about the education system, or else we are deceiving ourselves at the peak. The root is very important to feed the truth. So start thinking about yourself. Even as we do this, I'm not watering this down. This is very important, but I'm saying we should also mind about what is going to feed into this. Tomorrow you will not be here. And even if you are here, the population is growing, you alone will not be able to serve all that. It will be a huge issue. So this should be the approach, this should be the direction that we take. Education, science, and technology. And this is what needs to be embraced in everything that we do. So the agenda for the ESTI is for human resource development and the state of education in general, to pick right from there what feeds in what. Nothing stands alone. Also promotion of science, technology, and promotion of youth development agendas. And so there are so many issues that we're going to get into this. The MP of North West Budama called me yesterday that he wants to bring youth to Faculty of Science and Education. He wants to come and train them in IT and so on and so forth. Now, Angela has just been here. We are moving very fast. IT is so important. And imagine the population that is left behind. A time is coming, and it is now, that we are operating many times hard, moneyless economy. What are you going to do with those guys there who have not gone to school? To date, you find people who move to the ATM, they look at them and they look for askari to come and help them. The times we were there, we had, for those of you who, the times we were using banks, we were still with Jesus. Let me remind you of what we used. We had booklets. You would open a page, and when you go to withdraw money, the teller would stamp on it. Is there anybody here who used that from Stanbic Bank? I told you were with Jesus when we were using those things. This is what it is. But things have changed so much. The ATMs started only for giving you money. Now you bank using it. And we're going on. Next time, with the Angela's things, you just appear that the ATM recognizes you. Oh, so what do you want? And you tell the ATM, you know, you just give me a few of these things, or transfer on my phone, I want to go the other side. Answer is that a possibility? So, but many of our people will be left behind. And this is where the issue is. That's why I'm saying we have to look at it in a holistic approach. So, protocols such as education for all, Millennium Development Goals, science, Millennium Science Initiatives, and so on and so forth. All these have been put in place to do this, but they are not yielding anything substantial. And so education for sustainable development by 2030 and so on and so forth, all those. But you see what we miss out now. Let me come to STI. The STI agenda from the Secretariat is a holistic one. But the way we pick it, we leave a lot more out. You see, starting from the foundation, schools and vocational institutions. And these matter a lot. But we seem to be concentrating here and there alone. What feeds into this is the question we should be asking, and we should mind about this as much as we mind of the center as well. And so every sphere of public life or human life is addressed in this. And this is made possible when we take it from ESTI. And that is the picture that I want to get into that next. Now the paradox. The paradox of the ESTI is here. And I like this comparison here. This is so many worlds and one country. So many worlds of education in the same country. So many. This school does exist. This is a school. This one here. Our chairman LC1, this one is my district. When this thing appeared in social media, I called him. Called LC5. I said, what is this I'm seeing? Is this true? He said, yes, this is true. I said, what has happened? He said, you know, people keep migrating and moving towards places where they can now cultivate, because where people are settling is becoming small and they can't cultivate. And the lands are very poor. Dr. Andima's things have not reached there. Fertilizers have not reached there. And that is his district as well. So, these guys moved very far to the end of the village. I think beyond their village there is no other. But when they went there to study, they also wanted their children to study. Rather to dig, they wanted their children to study. So they organized these schools. But because of the engagement there, they can't look after the school very well, and they don't have any qualified teacher. One of those farmers or parents who maybe dropped out before P7 goes very early in the morning to dig, and then folds those things and comes to teach these classes. Then I told him what I did. He said, you know, we are engaged in government. That's what is happening. This one also does exist. Check Wikipedia, you will find it on the state of education here in this country. This one does exist. Schools in this beloved country of ours. These ones are there. These do exist. And compare it with this one. This school, if you're in Kaleru coming towards Mulago, before Total, is it you does something like that? This one. And you see these children. Hey, they are using Angela's thing here. But this one, I don't know whether they've even seen one. And those ones. Now, the paradoxes. UNEB gives examination to them, assuming, I think they assumed that they were in this school here. Even for these ones, the same standard examination. When the results come and people are jumping, yay, you know, my child got 4. Let me tell you this. We should be very, very sad when this population does not do PLE or go there just to wait to get married. It's a terrible thing. I challenge UNEB over this one. I read their works and I work with UNEB on the issue of their research and so on and so forth. And this is one of my issues with them was, you know, the disparities. And we have 2 or 3 papers there concerning that. This is what is happening. The same examination. A person who escapes from here through and comes, you know, gets some 3rd grade in P7 and goes to this secondary school, gets a 3rd grade, comes to A level in another school, gets supplementaries, rather subsidiaries. Sorry, I'm very sorry about this. Gets subsidiaries. I want to tell you that person is far better than a person who gets triple B from Budo or Gayara. Because those ones, these parents, these ones here go to school at 10. These ones, they go to school at 10. And 2 or 3, they are back. Those who live in Kampala, you have relatives in Kampala, and they lived there. You wake up at 5 a.m. with the children, whoa, 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 whoa. And by 7, they're in class. And you come back with them at 7, sometimes 8. The jam takes you up to 8. Kids sleeping in the vehicle. What are you doing there throughout the day? Children cease to be children, and we deny them those things. Those of us here of my age, you know, we went to school. I put my first shoe when I was going to S1. It wasn't mine. It was my uncle's shoe. My uncle was a head teacher, and now the shoe had bent like this. He couldn't put it on. So I put my legs there and I fixed some things in front there. You know what I'm talking about. I started and I'm here today. So this is how serious the situation is. A person who gets O's in that place and in such a place, I want to tell you, is much better than one who gets that. Because even in primary school, I had my son in Green Hill. Those people, by first term, have finished syllabus of primary school. What nonsense is this? And from second term, you have your kids there. You know what is happening in Kampala there. Many of them. By second term, they are just doing exam. And you check their notes. They are answering questions all the time. No essays, no nothing. There are no questions they have never seen. And when UNEP comes and they pass, they get 4. What excitement is here? They are only examination-wise. They are not necessarily intelligent. Now you check the results, total skewed. Those who pass in first grade and so on are mostly in Kampala and in these cities. You mean the people in the villages have stopped producing intelligent children? I started from up there, from primary, in the same suburb of the town, up to when I went to S6. I left S6 from that very place. That's when I went to study undergraduate. I applied from there. That time there was merit. My application to Makerere to go to Dar es Salaam was on a 96-page paper. I pulled from the center, you know those things. No full scope, nothing. I wrote, I was seated on the veranda of our small shop. Then my friends who were in A-level came around and said, "You man, there is this thing." I gave it to them, they took it to Makerere. And there were very few. Makerere checked through, I qualified, they admitted me in Makerere, and then also they admitted me in Dar es Salaam. And who would not want to go out? So that's what happened. But that is not there now. Things have changed. You can't pass from those villages to come to the university. It is not possible. So this is what has happened. Can you go forward and do for me that as I complete? This is a government-aided primary school. That is the NTV report. Can you report and get the volume? That is a primary school. You see that number in one class, 400 something in one class. There are 400 something in one class of P1, and the teachers, there are no space for standing, and the teacher is everywhere. A government-aided school. And when you find schools in cities, when you find them in, urban areas, in one class of only about 60 pupils, there are two teachers, one seated at the back, one in front. Have you seen those? Or I'm talking, these younger people, they don't have children maybe. But those who have children, at least you go to visit, you see what happens there. Two teachers in a class of 50 or 60, they may have even 3 teachers. That one. 400, one teacher is shouting herself hoarse. By the end of it, a full year you may not know all your children. So this is what is happening in that place. So if you can, you just play it without passing it through there. So that is the situation. That is the paradox I'm talking about, if we are picking from education. Now, connect it back and we'll go. So now,
out of 470 learners, around 70 may pick exactly what I was delivering, but the rest may be left in dilemma because I don't reach to them one by one.
According to Scovey Abodia, the class teacher of P1 at Ombatin Primary School in Terego District, last year she had a total of 474 pupils. But however, in third term only a total of 250 were promoted to primary 2.
400
something, 200 class that has a total of 300
about started at P1. Okay. Now you go to my slides. And if you want, there are so many of these. If you listen to NTV has been following this in environment districts. And there was one in Budaka here. The classroom was under the tree, under the mango trees. So 4 classes under the mango tree. Another here, they put bricks. They are facing this direction. Another one there, and so on and so forth. This situation is here. And where is the sustainability we're talking about? And there are very few who come through that. When you look at those pictures and that video there, you know, under these conditions, so the question of sustainability and inclusivity comes in here. Under those conditions, who can proceed with education under such conditions? One or two. And those who come have 3 or 4 backbones to pass through those conditions. And that's what it is. It's such a difficult thing. And then who merits to get to higher education? And that's why Tayeba was the other day saying, you know, we rather leave it for the other. It is the same people, it is our children who can go through, even get that when we can afford to pay. Who merits to get government scholarships? So these are the kind of things. So the disparities represented in the pictures, so, sorry, grave, and the disadvantage so much, basing on, so the results of those children results that we see here from the rural areas are not portraying individuals' natural abilities. They are only portraying, or they are dependent on socioeconomic status, not natural ability. And, you know, dependent on the urban, rural settings. So the potential andimas, or bakiros, and, you know, rahuires or ricos are left behind. Many of them have been left behind there. So you are suffering alone here. I heard you here saying, you know, other people will do this part, you want many more of them. They are not there. They dropped out. So we must, as we go this way, check where we are coming from. And that is where the issue is. Many have been excluded. Many very intelligent people have been excluded. I want to tell you, a very intelligent thief is very dangerous. And it doesn't come the way you are, you know. They also use, they learn crude IT, and they still use smart. So this is the kind of thing that is happening. Next, and we are going to complete now. So how do we achieve sustainability and inclusivity in ESTI? And altogether, we must change the state of education in Africa in our time. And so I want to take all of you, as you are doing this, you should interest secondary schools, you should interest primary schools in whatever we are doing, and go right down there. I had the opportunity to go to Singapore. In primary schools, what those people do, you can't believe it. These things that you're talking about here, they will, you know, do those cycling and whatever it is, many more technologies. Let's do what we are doing here and think of sustainability in terms of impacting down in secondary schools and primary schools. I only know of the math people in my faculty who keep going here, interesting people in mathematics. And so the others should join them, and we go right down there. And so we must surely change. We must change. So all these, we should embrace this agenda. We should embrace all these changes that are being proposed. Take the bold step to be counted and be one of those who will take part in influencing education in this country, right from primary school to achieve sustainability and resilience. And so, in conclusion, the school environment leads to poor performance unless you listen to this. Those 470 children, if you cannot keep one child like this, you tell the child, you sit here, let me bring this. The moment you reach that corner, the child is next to you here. How about 400 something? It's a very serious thing. So we must change this, and that poor environment leads to poor performance, leads to poor performance in the science subjects in the secondary school and whichever it is, and the perceived and actual inadequate practical subjects and so on and so forth. I now want to give you this as we move in this. We propose affirmative actions to be taken. Anyone who has sailed through a level is capable of learning anything. And you should know this. We are stuck to a very wasteful education system, and yet we have education system that is very accommodating. We can have them. Right down here in South Africa, admission to university is not based on A level only. They have some schemes for people to join university even at O level. And you'll find them in university and great innovators come out of them. The same in the US, the same in different other places. And we're here obsessed with A level. And when the higher you go, the difference that you see in the class environment becomes wide. So we are proposing to have affirmative actions and bridge the knowledge gap through educational innovations such as higher education access certificate. And you should create flexible shifting from arts versus, or arts to science, science to arts. People should be very flexible. People are capable of learning anything. I'm a chemist and a psychologist. People are capable of learning anything. This brain, don't joke with it. But the people who've gone here to Europe, to US, they have gone to Russia, wherever it is, with the arts, whatever it is, and they come back as doctors, they come back as this. There's no miracle in any of those things. Psychology tells me at this level, you are now capable of learning anything. It is your attitude that actually imprisons you. You can learn anything. Right now, at this stage, if you want to go and do engineering afresh, you can do it. And learn those mathematics and so on and so forth. But our attitude and our obsession with a system that has already been left is what is imprisoning us here. No wonder we are moving backwards. And lastly, I want to thank you. When we work together, this thing will stop being as it is, and we'll work together and we see the direction. God bless you.
Thank you very much, Professor. At least you confessed. Let us give him another round of applause. Thank you very much, Professor, for that wonderful address. And we appreciate for you educating us on sustainability. Actually, if you, Dr. Kamoga, I don't know whether he's still here. I don't know how many of them are here in Uganda. Those who are the specialists in the paper and technology. You always talk of there are only two. At this juncture, I want to hand over back the microphone to the Secretariat to guide us what next. I know they have some detailed communication to give us.
Yeah, thank you so much, everyone, for today, and I think it has been wonderful. Thanks for sitting up to this time. Admittedly, we started a little late, and then somehow things were interesting and we overshot. But I think that's expected sometimes. We've come to the end of today. I think there are two presentations which are scheduled for today, but these will be shifted tomorrow. We should be able to fix them, and this should be done tomorrow. And so tomorrow, let's try to keep time. We will start exactly at 8:30. So if we keep time, we will actually have all the presenters present their work. There's transport, as already announced. There's transport to take everyone who is going to town. So the bus is ready. You'll go board and will be delivered to town. But before you leave, I think there is supposed to be evening tea. Is that correct? Yeah, we have some tea that's out. After all, we had late lunch, so it's really good time to have some evening tea. And then you can stretch around and see what this campus offers. Yeah, there are lots of things to see around here. So as you take some evening tea, yeah, you can also move around and see what Busitema offers for those who do not come from Busitema. It's a safe place, so feel free and move anywhere. And then for the presentations tomorrow, okay, I should make it clear there are actually going to be some awards. And there's a particular category that will have, I think, cash prizes. Yeah, this is sponsored by one of the projects within Busitema. And so we keep taking notes. That means when you have a presentation to make, you really have to do your best. Yeah. So that's what I thought I could reveal to you. So do your best, and yeah, you never know, you could be one of the winners of the awards, especially the young scientists. So I think those are the things that I needed to communicate now. But I don't know if there's additional thing. Yeah, okay, so let's keep time tomorrow. The bus will leave tomorrow at 7:30 from Tororo. Have a nice evening.